because what I tend to do is on my other screen, I'll pop out the side chat, and that's pinned on the right hand side, and then this Zoom panel I will slide over so that sits over what's showing on YouTube. There we go, muted that. So if I slide this over, I can see the side chat. I can, obviously I've got the Zoom window open, but that's over the top of what you're showing in YouTube. So I don't see YouTube, and I don't see the fact that it could be several minutes before somebody in the side chat goes, "Oi, you can't see what you're talking about."
Yes. So that's all right. That's why I don't mind people having this chat on, because if I'm not reading the chat or whatever, because I've got the chat and what's he? Hey Clive, how are you? Oh, okay. Goodbye.
Just got here.
Just got here. Has your power gone out already? Hello, panel. Armageddon, can you hear the panel? You should have heard that very enlightened yawn from farmers.
I hear the power cuts in South Africa have gone to stage 6.
Stage 6.
Yeah, they have 4 cuts a day.
Oh,
it's
so annoying.
Like terrible. Yeah.
I bet you the cost of batteries and solar cells have gone up.
Oh, I mean, bet you boost. They keep threatening that if we don't do something soon, we're going to start suffering brownouts over here, because our traditional power generation hasn't quite sort of kept up with demand and such like. But we're getting more and more fields covered with PV arrays, and there's turbines all over the place. So hopefully we might just make it through without it.
Yeah, well, I've had internet troubles today, but I think I'm okay at the moment. I haven't had trouble for a little bit. I did have a little panic, as you do. I was setting up. I was going to use Google Earth. I use Google Earth without any problem. Blah blah blah. And then I had it all set up, and then it just died. And then every time I ran on it, it wouldn't show again. So a few reboots, resetups. Yeah, eventually I got it going again. But it was like never any problem till, of course, I was going to use it tonight. It was a problem. It should be working. If I sit over here, it should be able to... If you put the right button. Which Google Earth? That one. There's my Google Earth. There it is. Transition. There you go. Google Earth.
Oh, did you see Russia's May Day parade?
No, I didn't. Did they have anything good going?
The T-34 tank.
All right.
That was it.
That was the whole of
T-34 tank.
You didn't watch anything else before or after that, did you? Just tank came up.
You know where everything else is, don't you?
Yeah, it's all in Ukraine.
Yeah. I mean, usually it just goes on forever, and it's just, tanks and rocket launchers and Christ knows what else. They did a while back, they restored a whole bunch of T-34 85 tanks. I think they found some that were in pretty good nick already.
Oh, is this it? Hang on, sorry. I just found Forbes.
And then when you get to the tanks, it was a T-34. Usually, I mean, you get tanks after that, and they just ain't got them to spare.
This is it.
I think they've got trucks, but
Moscow's a single T-34 tank. That was it.
Yeah.
Yes. Well, I mean, obviously, yes, they are doing other things.
But it did make me chuckle. It's like, is that all you can do? A restored World War II tank? But when you're shipping that off to the front,
Yeah. I suppose everyone's going to mock them anyway. Is this it?
And can I just point out the Zebulon? By the time we get round to Lindsay, this will need refilling.
Yes.
I
That's
guarantee it.
Nerd.
Yeah, I mean
What's wrong with
that's a well restored tank. That is. That's a T-34-85.
Yeah.
But that was the only tank they had.
Well, it's well pretty, but it does look a bit bad on that other.
Well, apparently this year they reckon there was about 50 vehicles on the parade. Usually there's upwards of 200.
Actually,
it's quite a show that they put on. But this year, no.
Did they have any of their ICBMs and all that sort of stuff? Because like I said, that would make more of a statement by not having them. Would sort of almost say, "Oh, we've got them planned somewhere."
I'm not sure whether they bought the nukes out. I mean, they had sort of. I think most of what they had was what you'd call support vehicles. Bless their heart.
I've got too many panels. That's not what I wanted. That one. Yep, put us back up. There we go. Ah, yes. I was hoping Blue might turn up. He might turn up later. Let's see. No Alan. No Matt. I'm just going to check. No. Hello, Judy. How are you going? I was going through my list. I like to do a whole have a list of dead air time. Let's play this type thing.
Oh, they did get the nukes out.
Yes. So I found some CC. He didn't mention winning the top left award. Maybe he doesn't even
funny
know.
that, eh?
Maybe he didn't know. Or maybe he's just not going to acknowledge it.
I honestly think Lindsay's more top left than CC.
Yes.
Yeah.
CC only won because people thought the video was funny of his wife telling him he's an idiot. That's really pretty much it. There's a lot more people who are top left than CC. Because the thing is, he's just ignorant. He doesn't seem to know anything, as opposed to some of the guys who pretend they know stuff. Yeah. So,
Black Sword should have had it.
Flat Sword, do you reckon? I was looking through. You go.
I mean, come on. Lindsay reckons he's a candidate for how many Nobel Prizes? Yeah. If that doesn't make him top left, nothing does.
Yeah, but he's just not got the coverage that others have. I mean, if Lindsay was doing live streams and talking to people,
if he was on different channels and sort of arguing with people, but he doesn't do that. No.
Doesn't do any interaction at all, and I think that's a big thing. Oh wait, he must get some. But
wasn't he on Globebusters once?
Yeah, he was once. Yeah,
I think he was. I think even they sort of went, thank you very much.
He was a bit too weird even for them.
They sort of politely entertained him, and then it was like, what the hell was that?
Yes, get him off, quick.
Yeah, when you're too much for Globebusters, then
You know how we watched that thing on Banjo? What is his name? Flat of Banjo. He's got a second one on that time zones. We watched that.
Hello, everyone.
You want to listen to that? That's fun. Got to do that. People like to see. He's done a follow-up one on time zones. I'll just skip through a little bit of the front bit. He's got what's he guy? Yeah, here we go. This is
only the northernmost part. You will note that Alaska and Canada are stretched to the west, and little by little they overstep the time zones on their left. They have set further and further to the point where in Alaska, at the Bering Strait, it is 3 o'clock local time, whilst at the same time and in the same place, it's also midnight in Russia, on exactly the same longitude. 3 hours are missing here, from 0 hour or midnight in Russia to 3 in the morning in Alaska. To the west of the Bering Strait, it is the same thing. We see that there are 2 hours of time zones missing, the 18-hour and the 20-hour ones. Therefore, in that
What I don't get is, why is time zones important at all?
Don't know.
northern parts of the globe, there are only
'Cause
19 time zones.
It's not the only one.
24.
I know
By
it's.
stretching Canada
I
or
think
Western
it's
Russia
something
to
in there,
less
right?
time zones here and there, it creates space
Just
at the
move
very
that down a little bit. I think it's some sort of idea that somehow it's got to do with the, the Earth is actually wider in the southern hemisphere or something rather. I don't know, but or whether it's just part of their conspiracy nutty stuff. I don't know. But the one that got me was, let's see if I can find it, where he talks about Australian time zones. They're all the same sort of guff, as you'd imagine. Where are we? Go back here somewhere.
Burma or Australia. And in these cases, it's impossible to know how the 32 time zones would be overlaid onto a sphere, since there are areas that are not habitated to the south of these territories. The 32 time zones disappear at sea, which is pretty convenient for the manipulators to hide the anomaly. We also see that USA and Australia have almost the same width on the globe, 4,000 kilometers for Australia and 4,500 kilometers for the USA. This works on the globe. They also have an equivalent latitudinal position, though the USA is a little farther north than Australia in the south. Their positions in latitude are similar enough to be able to compare the time zones for each country according to their width. If we superimpose their position and width on the globe, we see that the width of the time zones between the north and south relative to their latitudinal position are not enough to justify a difference of double the number of time zones. In fact, we can see that there are 4 time zones over the USA and only 2 used in Australia.
Yeah. So we apparently only have 2, Paul, for a start. And,
Well, that's wrong.
No, it is. He does mention it, but
Both countries have the same width. In the middle of Australia, they have added an extra half-hour time zone to make us believe in a third time zone. And in this incorrect projection, Australia overlaps the 22-hour time zone.
Make us believe in a third time zone. Well,
yeah,
third time zone.
it's apparently there. It's apparently there, but we don't use it. So
Use 2 time zones, which are shown here.
Try telling that to the people who live there.
On the time zone chart, Australia appears a lot skinnier than the USA, even after stretching it over the 22-hour time zone. In my opinion, it's not real because this time zone is ignored. The difference in width comes from the time zones being parallel in this representation. In the flat Earth, they get wider to the south, which correlates with the entire width of Australia, only using 2 time zones instead of 4 time zones for the USA.
What the fucking map was that?
If we place the USA and Australia on the time
it's all like, what difference does that make? Anyway,
zones on the flat Earth, the time zones used by both countries makes more sense. Since the time zones don't widen as you go south, it is imperative to stretch the land masses in the north so as to keep the time zones parallel in order to maintain the illusion of a ball with 2 symmetric.
I'd like to point out that we've got 3 time zones, although he thinks we only have 2. 3 time zones. This part of it also has 2 time zones in an area that's about a fraction of the width of here, but he doesn't like to mention that, does he? So why have they got 3 time zones through here? We got 3 times through that length. It's got nothing to do with it. It's the countries decide what time they're going to run.
Yeah, exactly. I mean, China's only got 1 time zone. Look how wide it is.
Yeah, poor buggers.
He's
That's got nothing to do with the Communist Party.
no. It's just...
hemispheres. We see that these
Actually, we should ask him about Greenland. Sorry. Greenland's only 1 time zone. You ask him, how wide's Greenland? Why is Greenland this wide? When it's, it's not really that wide.
I'll tell you why. Because there's no bugger there.
There's no one there to complain about the map being that distorted. That's
So
why.
pretty much most of Greenland is uninhabited,
Very unexciting stuff up there, yeah. So, that's it. Oh, so it's going to be very quiet tonight. That's a shame. Oh well, we'll see. What have we got? I was going to say, do you want to post your clue, Paul? We'll see if...
Oh, okay.
who we got out there?
I can do that.
I think we've got enough. Judy, let's see who can find your clue.
There you go. Posted. That was quick typing, wasn't it?
It was. Not faster than I could type. Mathematical engineer. Today, scientist is Hungarian, mathematical engineer, and physicist.
I already got that before you put the clue up.
You worked out who it was? What?
No, I didn't work out who it was. I cheated.
Ah, can I guess the middle's Van? Or
No, it's not Van.
ah,
If it's not Van, then it must be
The other one.
the other one. There's really only two options.
oh dear. So you worked in aeronautics.
And I have actually heard of this person. I think most of us have, because some of them are a bit sort of who, but this one, no, we've heard of him.
Super has it. We got Etvos.
Not it was.
That
Not
doesn't
Utfos.
fit. That doesn't
And
fit the. That doesn't fit the letters. No, no.
what spelt with a silent K?
Yeah.
Your mum.
No, her
Standard.
name's too long. Doesn't fit. She's got like 5 names. She comes from a Greek family, so and they're all long, horrible things. I could never
Want to give a
spell it.
clue to your own farmers? A
Go on,
verbal clue?
farmers. Give us farmers. Give us a clue.
Oh, a clue that doesn't give it away completely. Shit.
Yeah. It's hard, isn't it?
It is hard because there's an obvious clue, but as soon as you say it, you go, "Oh, right, yeah, I know who that is."
Yeah.
Ooh, that's a bugger. No, I'm just having a look now. It's all. No, that give it away.
Alan can't come tonight. He's got grandkids. Just so you know.
Oh yeah, I see him in Discord.
I haven't tried Google Foo yet. I'm getting down to Google Fooing. Google Fooing. Let's see. How long can I take to get Google Foo?
Ooh, one of those was a typo.
Oh, yeah. No, looks like he's one of the lucky ones. He got out in time.
Alright, I already know who he is. He's got a name similar to Bolero, the maker of Bolero. Except it's not spelled the same. Bolero? Did you know Bolero?
I know the piece of music.
Yeah.
And I do know the music.
But these two characters did some ice skating too once upon a time.
Yeah. Hang on.
Joel and Dean.
Am I getting it?
But yeah, about the only bit of ice skating I actually enjoy watching because my God, they nailed it.
They did.
I remember watching it the first time round in 1990, whatever it was.
Yeah. So who wrote the music to that piece?
Ravel.
Ravel.
Rafael.
Yeah, and what was the name of the thing it was in?
Oh right, right, yes.
Yes.
That's a top 10 US, isn't it? Eh? Oh yeah, right. Okay. Yeah. got there in the end.
Yeah. That's the link. See? I don't see the letters. Where'd the letters go?
Well,
Does that-
they're,
No,
they're
still
there
there.
in Zoom. They're in the
And
side
they're-
chat.
That's there in the side chat. Yeah. Oh, sorry. That was yep. My chat was out of order, so that was before you
Ah,
posted.
right.
those.
Okay. You put it on live
no.
chat, not top.
So Ravel. No, it's not Ravel, but Carmen. Yes. So
Yeah.
Theodore Van Carmen.
Not
Carmen?
Van.
Von
Von.
Carmen.
Von.
Come on.
Von.
It's either Van or Von, or we eliminated Van early doors.
Yeah, it was one of those. I said it wrong before, and then it stuck in my head. Van Carmen. So there we go.
And of course, the biggest clue would have been he's got a line named after him.
He's got a what named after him?
A line.
A line. Oh, Carmen line. Oh. Ah, there you go.
The,
Oh,
the
I didn't
so-called
pick up-
point at which you're in space.
I didn't pick up on that, but yeah. There we go. Another thing to remember. I did look up, I'm going to say it wrong again, aeronautical jets. Just talk.
Well, that's
What?
probably better off to think of you've now reached the point where your aerodynamics are achieving zip.
Aeronautical, not aeronautical. The space jets. I'll call them
Space jets.
Yeah, I'll call them space jets.
What space jets are you talking about?
The ones we covered last week. Last time. I'm
They're
just thinking,
not aeronautical jets.
no, I know. I said I was going to get it wrong because
Oh, dear.
it's aero something. Aero astronomical
Astro-
something or other.
Your
Yeah.
memory's as bad as your spelling.
Yeah, I don't know why that one would stick in my head. It was just like, and I even read about it. And I was thinking, I'll have to remember that. And then I got here and I thought, no, I can't remember it now.
Astrophysical jets.
That's the one. I knew it started with an A. Anyway, well, will we do a Lindsay? Do you want a bingo? I did a new bingo card.
Hang on, yeah.
I did a new bingo card that so we can do.
Oh no, I'm out of tea.
We can get a line this time. I'll paste that in there. I'll paste it in here as well. So you can get a row. So it went 4x4. I added a few extra words in there. So rather than trying to get 9, you only have to get four in a row. So what do I get if I run that? So you should get a card like.
Pretty good mix.
Should get a card like that. If
Yeah.
if the people click on that one. Never heard the term either. Astrophysical jets. It was astrophysical jets, yes.
Or are they astrometaphysical jets?
No. There was a and what's really bugging me is another name for the top. It starts with R, and for some reason Ravnik sits in my head, but that's not what it was. Type of jets. They had another name. Anyway, doesn't matter. I'll have to reread it again. Okay. Back to Lindsay. I think I got him. He's not in front of his whiteboard this week. Well, we're a few videos behind in terms of time wise. Since I'm only
I know he's been putting out quite a few recently.
since I'm only playing one at a time. So
Oh, it's a short one. Oh, good.
it's a short one, yeah. So let's see what he's got to say. See if we can get some points. Oops, I can't see my bingo card. Hang on a sec. I'm going to drag my bingo card off. There we go. Back to there. Okay, let's push play.
How can you put black hole in the middle?
Welcome. Sorry? How do I put black hole in the
No,
middle?
Zebulon's just said black hole should be in the middle. What? In a grid of 16 squares? How do you get one in the middle?
Zebulon, it's a random for everybody. You've got a different set. Everybody's one is different. I've got
Well,
black
to a
hole
point.
Yeah, mine's black. I have black hole, but it's down on the bottom right. So
No, mine's.
otherwise, everyone would get bingo at the same time. That wouldn't be much fun. Oh, there you go, Johnny. Just in time for Lindsay Bingo. I'm sure that was what you were looking for. Okay.
Few Lindsay videos. I'm not sure about that.
Sorry?
Might be a rebellion.
Okay.
So we say, oh, we got time for 2.
Got time for 2. Well, it's only short. Do you want? I can do 2. Okay, let's go.
Oh, no, don't feel obliged.
Welcome to another video here at the Tomb of Illumination.
What can I hear him?
Today we
Can you hear him?
No, I can't.
That's a bit annoying. You could hear Banjo before, though, couldn't you?
No, I couldn't.
No.
Ah. So you could have told me that. I could have fixed it. Why can't you hear him? Here's a good question.
Because we had subtitles we could read before.
we're going to talk about magnetic flux.
Okay, hang on a sec. Let me try. I'm going to put my audio.
I mean, Lindsay is a silent movie, isn't anywhere near as entertaining.
No.
Let me try this. See if you can hear this.
Of Earth and
Is
how
that
it's
better?
like a ring magnet.
Yeah, I can hear him now.
Just need to bring
Yeah.
the volume up a bit.
How you're not
I can turn him up. There we go.
taught that
Oh, I got to start again.
illumination.
Yep.
Today we're going to talk about magnetic flux of Earth and how it's like a ring magnet. How you're not taught that basically because you're taught you live on a spinning ball. You live on a ball. No, load of garbage.
I've got to put that in
The
next week's
magnetic
ball.
field does
Spinning
not
ball.
move from the south to the north. It cannot, because the magnetic field of Earth does not cross the tropics, does not go across the equator.
It does, though.
The
does,
sea
yeah.
currents and the winds, they do not cross the tropics.
Oh, dear.
Oh, winds don't
The
trust the
magnetic field
tropics. They
on
do
either
too.
side of the tropics, Cancer and
Oh,
Capricorn, drop
magnetic
straight
field.
down to the ground vertically.
I got
and
that.
pass opposite to each other's pole. So you've got the flux coming out of the centre north, goes over to the Arctic, Tropic of Cancer,
Yes.
drops
that's
to the ground, then along the ground thou shalt go, and then up and over the field in the south, comes out of the Antarctic, up and over the field, over, drops down at Capricorn, to the ground, along the ground thou shalt go, and up and out of the North Arctic, centre Arctic.
But it doesn't.
No.
So you can see here
He's just making shit up.
the two fields for
He
a
is.
starter. There's basically a toroidal field, okay? So imagine a toroidal field.
Yeah.
You've got that centre part inside a toroidal field, which represents the north. So there's the North Pole in there.
I'm sorry, Lindsay,
This is
but
all
a
the
toroidal
South Pole
field
around the
doesn't
outside.
describe what you just
Really?
described.
No. It doesn't look like a toroidal
I
field,
mean,
does it?
a toroidal field doesn't do what he just described. So
No.
I don't know.
Yeah. But since when else has he been right? So
Well, it's the South Pole. If you work on a cycle, a figure eight cycle, the North Pole, the north end of that cycle, like the north end of the sun's analemma,
and why is the south so his supposed southern here is so big and this tiny little thing is this little North Pole and this massive gap? That doesn't meet what he says it does either. So
it's 33% smaller than the southern field. There's cycles. So you can imagine sun analemmas, figure eights all the way around, flowing all the way around. It's a continuous cycle moving west. That's in the poloidal. Earth has a sun. That's what creates that movement. But in a magnet, it's not moving. It's just stagnant. Straight up in the south. And then you have your north. So these ring magnets are basically...
But
what
it doesn't
I
look
think
at.
this is. I could probably say it's not.
But aren't the looking at the metal filings, they don't follow the shape he's saying they do at all.
No, of course they don't. Well, don't let a fact get in the way of a good story, though.
No, it's like, it's just
Quite.
what he's based his whole. Because I remember watching very one of his early videos. He based his whole thing on this rig mount. It doesn't look anything like that.
But to me, it's still radial and axial, because radial is flowing up and over to the Tropic of Capricorn,
But it's not.
through the ground, up and out of the centre north. So, because we've got the dividing line between these two fields, see, will be the axial point. That's the tropical zone between the two fields. It's the avoidance zone. It's the dielectric.
Avoidance zone.
Avoided side. I have.
The zone of avoidance.
Can I get tropical zone being the same as tropical gap? I have to make a clue on that.
Oh,
That'd be good.
nah.
No.
No, it's not the same, is it?
Not the same, I suppose not. Yeah, keep going.
On Earth, because that's where we imagine the sun's flying around, because
Oh, that's
it's a
but
long
the sun.
story. Check out my other videos. But it's the moving sun that creates this radial flow of the changing magnetic field going to the tropics, down and up and out. That keeps us infinities changing magnetic field going because of the sun moving around, which is electrical, right? And that changing magnetic field helps make the sun move around, and vice versa. So what came first, the hen or
So
the
what's-
chicken?
So what's the sun made of?
Magnetic field or electrical? Well, in this case, if you think deep, the magnetic field was there first, but it's all about frequency. It hit the right frequency. Due to the wind, we don't hear it. We don't hear that frequency. In the Bible it says the four winds, the meeting of the four winds created the vortex, the spin in the centre north, due to the hot and cold temperatures of Earth, right?
Doesn't say that in the Bible.
And that
at all.
vortex created
Yeah.
a spin, and that spin hit a frequency, and that frequency ignited the sun. That's how we got our electrical.
What?
This is how we get electrical from magnetic field on Earth, but it's all hidden from us.
So how does the wind, which is not magnetic, ignite the sun, which then is somehow controlled by the magnetic? So what's the sun meant to be made of? That doesn't make any sense. Funny enough, it doesn't make any
no
sense.
sense at all.
No.
So it's hitting the right frequency. So if you get a magnetic field, well, in Earth's
Ooh,
case, we
melted
have the
cheese, that'd be
temperature
good.
variance. So maybe we could hit the right frequency using other methods than using the hot and cold system, the winds. We could create a frequency maybe somehow. I'm not sure. But anyway, that's how we'd get our free electrical from this magnetic field.
What free electrical?
But anyway, I want to show you how the field comes out of.
Was he the one who for a long time ago was going to had this device that was going to produce free energy? And if you paid $500, he'd tell you how it worked? Or is that a different guy?
I'm not sure now. It rings a vague bell, but I can't think whether it was Lindsay or not.
No, it was a while back. I'll have to look into it. Okay.
Of the north, centre Arctic north. Well, actually, it's going in there, so this might be the other side. So you still got the flux on the outside.
Yeah,
the
let's
southern
fluff it
field
up.
as opposed to the northern hemisphere.
Get it the right shape.
Let's have a look. See that right out of the centre. You got a divergence
That doesn't look
coming
anything like
out
your pictures.
of the centre north Arctic quite clearly there, right? All back there.
Gee.
You see it shooting out all the way, shooting out. It's shooting over to the Tropic of Cancer. dropping back down at the tropics, in between the centre and there. It's dropping back down at, say, Cancer, but then you'll see it flowing from that point out over this way. That's what the field does. It'll flow from Capricorn over to the south. That's all the southern field that's flowing over from the Antarctic right over to the Tropic of Capricorn. And within that northern region, you'll get a flow coming out and over to Cancer. So that's above Earth, the divergence from the centre. You see it all flowing out. But then you turn it over. It's very minute, so you can imagine it coming out of the Earth this way now. Very minute, because before it expands outward, which I've just shown you, the outward flow at the top. You've got to imagine a very small inward, which is very hard to see.
Because it's not there.
Dead centre, it is going in. There's a little in zone right in there. It's probably about 5 mil in diameter, where it does actually just run inside. There's centre right there. See, it's just going down and in. It's all going down, isn't it? See?
No.
Oh dear, no. Oh man, this is funny.
So if you imagine it like that, that's still just the flux of the Earth.
I get
along
what,
the ground. Thou
what
shalt
I can't
go.
get is
You
how he
feel
thinks
the
one
flux.
side is different than the other.
It's a magnetic field flowing through the ground. So you've got to see the flux somewhere, don't you? But it's going up through the Arctic and out like this. So it's quite clear there, isn't it, guys?
No.
The two fields, there, the tropical gap. So you call all this the south. Tropical gap.
Yeah, it doesn't do
right
what you,
tropical gap is right between the
what
two
you,
fields here.
what you
actually.
say it does.
This is flowing up and over that way, see? So the tropical gap is right there at the dividing line between that northern, that flat zone and this expressed out field. So we have a north and a south pole on top here with these magnets, but you also have a north and a south down the sides. So you have the south and a north here.
Don't think you do you?
No.
No matter how many magnets you use, it could be just
No, you
one little
don't.
magnet, but I'll put two to make
Oh,
it
dear.
stronger. So if I took that bottom one away, you'd still get the same, but you'd see less of it. It's more obvious if you use two.
It's not obvious at all.
Flux there. There's still that neutral zone between them, you see.
No, you're
No
telling
matter
us it's
how you
there,
cut a
but
magnet, you'll always have that neutral zone.
why the
And
stuff's
in our
going
Earth's
there if
case,
it's
it's the
neutral?
tropical gap.
Oh.
Okay. Cheers, guys.
Quick. Answer the phone.
Shall just make a point. I'm not sure I mentioned it. So really, in this case, it is poloidal and toroidal.
Poloidal.
Poloidal is the electrical, which creates the movement like this.
What?
But toroidal.
What is that word you are using?
He's saying poloidal, isn't he? Like as in,
I don't know.
is that an actual word? I hadn't heard that one before. Or is this his Nobel-winning prize word? I don't know.
Is flowing this way, back in like this, or out.
Answer your phone.
Which is
Come on.
basically the radial. And that, the radial. And then you've got the axial around this way, which would be the poloidal.
What?
Okay,
That's the
cool.
axial and radial. It was. Well, I didn't get very much out of that at all. I only got torus field and magnetic field. Anyone do any better?
Oh.
Anyone else get bothered through?
Taurus field, tropical gap, northern hemisphere. I think that's about it.
Yeah, I wasn't the best.
And nowhere near forming a bloody line. They're all over the place.
No. If I cheat and said that he said vortex and black hole, I win.
I mean, he's got it in his mind that the magnetic field does this magic figure eight thing that dips down through the Earth at the tropics, but in reality, it just doesn't do that.
But it doesn't
It
even
goes
do that.
almost parallel to the Earth's surface. So there's a dip, right? And we can actually predict that dip. I mean, if we use Maxwell's equations and the Laplace equation, we can actually calculate the dip angle of the magnetic field, and it matches pretty closely with reality. I mean, the tangent of the dip angle of the magnetic field is equal to twice the tangent of your latitude if you work it out.
Yeah.
I mean, and this predicts it, and it's pretty much bang on for most of the world. I mean, the magnetic field does have some odd shapes in odd locations, but for most of the part, it works fairly well.
What gets me is that it doesn't do what he thinks it does. Just even his magnets.
No. No.
Where's he getting?
And I mean,
from?
the magnetic field of the Earth has been investigated pretty thoroughly. I mean, you would have to investigate it pretty thoroughly because lots of people depend on knowing how it works. I mean, like airplanes and ships that use compasses sort of have to know how these things work.
I was going to try and get Blue in. He says his Zoom's messed up, but maybe I can switch to Discord if that works for him. You want to do in Discord, Blue? Because I was going to talk about your stuff, so it'd be good if we can get you in. So, jump into the usual fair suck, and we'll sort it out from there, Blue. Yes, you're right. I don't know. He's getting more and more deluded, I think. I don't know. Also, probably because I've got him on normal speed, he just sounded really slow and tired. But I think that's just because I had him on normal speed.
It was only a short one too.
Yeah. So interesting though, you actually seeing his actual room. You can see this is his desk. His cell. It's not a very big space. It's a back room.
There's some very strange features in that room, which makes me wonder whether he's actually not in a house.
Yeah.
Maybe. But I think it was a couple of videos ago he sort of finished quickly because it looked like he could see some people were coming home. Because he let it slip once he had to do it while people were out of the house. So, I don't know.
Yeah.
Which, yeah, you always wonder, do they actually, anyone know what he's talking about? Like, anyone outside of us know that this is what he's doing? Anyway. No blue. No blue. Oh, hopefully blue. Can I drop blue? That's sad. Well, let's have a look. Let's play Blue's thing. He might be able to come in while he's... Otherwise, we'll just talk about him without him. Here. Okay. Where's his link? Blue. There we go. So, Blue put up a new video. Which I'm about to play. Recommend you watch it and give him some views. And we'll have a bit of discussion afterwards. Go.
Well, hello everybody. You know, they say never play chess with a pigeon because the pigeon will just knock all the pieces over, crap on the board, and then fly back to its flock to claim victory. A while back over on Red Rhetoric's channel, I got into a bit of a pigeon chess match with a flat earther that calls himself Mike Jones. So let's see how that worked out.
MJ, you chose that name, so that's what we will call you here. So, let's do a mic check first. Mic check, please.
You might want to turn it up a bit.
Okay.
Yeah.
Gentlemen,
Okay. Everyone can hear him?
Yeah, I can hear him. I can hear him fine.
Sweet. So, Astronomy Live, Big Blue, you are free to stay. Same with you, Slice Arcane. Piece of shit. So, all right, MJ, what the fuck you got for us?
so Blue Up, we were chatting this morning, and you said that level isn't horizontal, and you can prove it. And I was just curious how you plan to prove it.
When did I say that and where?
No, it's a little Blue. Not talking to you.
No, you want to know when I plan to prove it.
Yeah.
You haven't watched any of the videos that I've provided.
Well, we were discussing this morning pouring concrete, and you said we could definitely level it, and then you said it's definitely been made horizontal. And all I asked was, in your 100+ years of construction experience, who made it horizontal, and how did they determine it was different from level? And how did they do? And what was the process for making it horizontal?
Mike, I only know of one case where the idea of horizontal with concrete ever became important, and that would be with LIGO, or maybe some of the other interferometers.
And you have 100 years of experience, so surely you've spoken to the contractors who made it horizontal.
100+ years of construction experience. You're a funny guy, Mike. Are you talking about LIGO? No, I haven't spoken with the contractors. I've gone by the.
So it might not be horizontal. So the concrete foundation might not be horizontal.
For those that might not be familiar with it, LIGO is the acronym for Laser Interferometer Gravitational Wave Observatory. We have 2 of these here in the U.S. One's in Livingston, Louisiana. The other's in Hanford, Washington. These are Michelson laser interferometers. The laser fires its beam down 2 perpendicular steel tubes that are each about 4 kilometers or 2.5 miles in length. Over 2.5 miles, the curvature of the Earth becomes significant. It's important that the tubes be perfectly straight. That means that the pad the tubes sit on have to be adjusted to account for Earth curvature. So that's what we're talking about. Mike, I have assured you time and time again that none of the pads at LIGO are technically horizontal. They all lie.
Are they level?
No.
Are they straight?
Are you going to let him answer?
No.
These guys always want to talk about level and horizontal. They think the 2 things are the same. They are not. Level is a particular elevation. Level actually is all the points that are at the same gravitational potential. Horizontal, on the other hand, is a straight line which is tangent to a particular elevation or a particular level. Vertical is simply a radial, which is perpendicular to any particular horizontal line. So level and horizontal have 2 very different meanings. In the case of LIGO, the 2 arms lie in a plane which is tangent to a particular elevation. So there's a plane, and we'll make it tangent to a particular elevation at that point. The 2 arms form a triangle, and that tangent point lies somewhere within that triangle, like that. So obviously, since that plane is only touching that spherical elevation at one point, as you move away from that point, the distance from the plane down to that same elevation is increasing, and it increases at the rate of about 8 inches times the distance you are from the tangent point in miles squared. Here's the actual elevations at LIGO. This is for Hanford, Washington. The elevations begin at 529.63 feet at the end of the northwest arm. At the vertex of the 2 arms, the elevation becomes 533.78 feet, and when you get to the far end of the southwest arm, that elevation has become 537.88 feet. These are the actual elevations that are measured and presented in the as-built drawings from LIGO. Yeah, they are straight. And you see
Great.
the curvature.
How did
You
they?
see the curvature.
Excellent. So they made them straight and they differ from level. Correct? That's your assertion.
Yeah,
How did they do that?
absolutely they do.
Did they make them like? Are they like
The elevations
ramps?
are different, Mike. Huh?
Are they ramps? You said they're not horizontal. So are they ramps?
No.
What's the
they're-
slope?
they're
Can you give me the
different
y? Can
Yeah,
you
I
give me
can
the
get-
y equals?
Can
the y
you let
equals
him answer?
Oh, fuck off. Y equals mx plus b.
Hang
I can
on,
give you the slope,
Hang
Mike.
on.
If you go out to
MJ.
Hanford, Washington.
MJ.
Both
I
of
under-
those arms.
Hang on. I understand this is usually how it works in someone else's Discord or
Dude,
live
you
chat.
just yelled at me.
Does not work here. So you will have to let him finish. You ask him a question, he needs to be given the time to answer. Okay? You can unmute now.
Go.
Big Blue, you have the floor. And if you need him to repeat the question, just ask him that.
Whoops, sorry about that. I was muted. Yeah, didn't realize it. If you go out to the Hanford, Washington site for LIGO, both of those arms have a 4-foot elevation change. Both of them. It starts at one end, and I can't remember the numbers off the top of my head, but it starts at one end of one tube, climbs 4 feet in elevation to the apex, to the center point where the two arms join. And then from that point, it climbs another 4 feet to the other end of the other arm. So neither one of those technically are what you would call level, are they? They have elevation changes. And the same thing is true.
Excellent. Can I ask a quick question?
Yeah.
So you've got a 4-foot elevation change from one end of one arm to the center, and then a 4-foot elevation change from the center to the other end of the other arm?
Yeah.
Yeah.
And so what's the elevation change between the two arms, the ends of the arms?
8 feet. 4 plus
Wait. The vertex, let's call the vertex 0.
Okay.
And you're going out to the end of one of the arms. So that's 4 feet up on a slope, y equals mx plus b slope, right?
That's on one of them. Yeah.
Yeah. And then you go from the vertex out to the end of the other arm, y equals mx plus b, and that goes up 4 feet, right?
Nope. Goes down 4 feet.
What an idiot.
Okay, so the difference between the two is 8 feet. If you were to draw a line, a straight line, and make another arm between the ends of the two, it's 8 feet. What's the length of that? What's the length of that straight arm? If you were to draw a line between the two on that 8-foot slope, what's the length?
What's the length of it? Well, they're about the arms are about 2.5 miles long. So could you perhaps square 2.5?
Shall we do the Pythagorean theorem on that one?
Oh, why don't you?
What?
Yeah.
Excellent. A squared plus b squared equals c squared.
What point is trying to be made here? Because clearly curvature is affecting the ends of the arms there. So what's the point actually being made here?
The question is, what's the process for making the concrete between the vertex and the ends horizontal or sloped according to y equals mx plus b along that 0 to 4 foot rise, as Blue says? One's a rise, the other is a
mx plus
fall.
b is not a rule.
One's a rise, the other's a drop.
No.
And if you were to draw a third line straight, that would be the hypotenuse, correct?
Yeah.
You're making
Excellent. So that's c squared. So a squared plus b.
I was talking. You're making this overly complicated for no reason. The process in which they're using when it comes to LIGO is that they want to keep the laser that's within that vacuum tube perfectly straight. It is level at the point of origin, but as the arms extend outward, you find that the curvature of the Earth plays into effect there. But still keeping the laser straight, there obviously needs to be compensation for the curvature. The fact that compensation is needed at all shows that curvature is actually there. Correct?
When it was built, you're saying that it's built at some point. There's a quote center of that ball, the top of that ball per se, and it slopes away from that point. And they've poured concrete in straight lines, one along A, one along B. What happens when they pour one along C? It drops 8 feet, Blue?
Yeah, it drops 8 feet. There's an 8 foot
8
elevation.
feet
8 feet.
on the hypotenuse. Thank you. It's been great, guys.
Anyway.
And
So you could defeat him that easily.
I guess it
I've listened to this multiple times, I still can't make out what his point actually is.
Too bad Mike didn't want to stick around. We could have talked about how those elevations perfectly match Earth curvature at the rate of 8 inches times the distance in miles squared. We could have looked at the actual elevations of the LIGO pad that those tubes are sitting on. That's not a straight line. But we could have done something really interesting. We could have plotted an inverse curve, an inverse version of that at the rate of 8 inches times the distance in miles squared, and combine those two curves, and you get the perfectly straight line of the LIGO laser tube. That's how you play pigeon chess. Thanks again, Mr. Pigeon. And I'll see you guys on the next one.
Yeah, that was just bizarre.
It was. So
I mean, he kept on saying y equals mx plus b as if that meant something. He was kind of implying that y equals mx plus b is some kind of gradient. It's not. It's the equation of a straight line.
Yeah, that's right. Ah, dear. Unfortunately, Blue is having trouble, so he's not going to jump in. Anyway.
I think Zoom did an update within the last few days.
Maybe, yeah.
No.
That might be what he's having trouble with.
It might be. I just realised I was going to share. I might have to do it. What I did was from the works executed data. Sorry, I'll just put this up. Do that so I can see what's going on. I went through all the as-built drawings, and hang on, I can do this. Let's do this. Straight to there. Transition. There we go. So there's a lot more than this, but all the as-built drawings. Come on, zoom in for me. Come on. So they point out that it's pretty unusual for a construction job to have this statement on there. So most Mikey wouldn't have got it, but see on their horizontal datum, they talk about how their origins run from this one coordinate, and then it is considered coincident with the plane. Don't usually put that sort of statement on there. You might say that's part of the coordinate system, whatever, but they're pointing out that the entire job's done on a plane, not on the shape of the Earth, which is important to note. So when you do the drawings, let me pull up, their elevation, of course, is on a plane, so all their profiles are drawn as a single horizontal, and so I went to all the effort of getting all those all the elevation levels from here, had to work in feet, which was killing me because I hate working in feet, but just out of principle, it annoys me. And from that, just switch back to that. This is pretty much the same thing that Blue had on his screen. So take all those changes in elevation, and then you'll you can see if you watch the grade will change. It's not consistent, so there's no consistent grade of the pad. You end up with that profile, which is the same as the blue only showed one side of it, but if you show starting with the southwest arm, comes down to the corner station, then from the corner station to, you can see that forms a curve. Now obviously it would throw it off because it looks like it's a funny angle there. If I actually did some radii test on that. I stuck it into my road program so I could work out what the radii of that profile was, And it works out within about 30, 40 miles of the radius of the Earth for both arms. They're not exactly the same, but the work it's as-built data, so it depends where you pick. And I'd have to do a full rationalization to get, what's the average potential arc. But it's interesting, it comes out. But anyway, by putting that in, I then thought, okay, how do I illustrate that? Because people are going to look at this and just say, well, that's weird, it's curved, but we know it's straight. So I took all that data, built the model in my program, and then I've transferred that to, sorry, I'm just getting it to come up. Here we go. Transferred that to Google Earth because that's probably the easiest I could think of to illustrate what's going on. So you can see the curve, but if I take that curve and then place it using the coordinate system that they supply, let's go to here. They're middle of nowhere too, the LIGO. So that view, so that view would look fairly similar to Blue's. The difference is that I've put that in as actual elevation now. It's a bit hard to see that because of the being so close to the ground, as you'd expect. So I have a slightly raised view, so you can see when you put that, what looks like a curve in profile because it's done on a horizontal plane for construction reasons. You can see when you transfer that to real life, it actually ends up as a nice straight line, which is what you'd expect.
Yeah.
Yeah.
Yeah. So that's just to illustrate that what they have done is correct, but there's no slope or grade or anything involved in that. And as far as the guys, part of I think Mikey's conversation was the that. So let's just pull elevation profile. You can see if I pull the elevation profile up, you can still see that curve shape because it's because obviously Google is doing this as a straight line elevation, as you'd expect. But you can see when you look at it, it's definitely not. And if I turn off terrain so that you don't have the hills, you can probably see it a little bit better because it's a little bit higher then, because it basically flattens out the surface. And I can sit that just there, and that looks like a straight line. It's straight across. Even though it's different levels all the way through. So I found that quite interesting. And yeah, so I think Mikey's trying to argue that they'd have to have slope or elevation to pour the concrete, because that was, I think, what started the conversation. But they're just going to use the levels that are shown on the plan. Surveyor's going to peg it out. They'll build to the levels, and they'll end up with the straight pad. So,
and of course, it's all built in sections anyway.
Yeah.
It's not like they're pouring it all in one bloody go.
No. So, yeah. Well, it's full. And what's that? It's roughly 2.5 miles, I think. It's 4 kilometres. 4 kilometres. Well, yeah. So it's 4 kilometres this way, 4 kilometres that way. So 8 kilometres total. That's a large pour. It's a lot of concrete. That's a real lot of concrete.
But so it's all poured in sections anyway because they had to allow for thermal expansion in the concrete.
Yeah. Well, when you look at
that's another reason why it's in sections, because it all needs to be able to expand and contract.
I know there was some discussion amongst the Bevites that it's just doing it within the tube. But so I'm just trying to pull up the what's your drawings again?
I think their biggest issue with LIGO, and the reason for all their butthurt is here we have, and there's not just one of them. Obviously, there's multiple of them. But here we have a construction that's huge, that they've clearly had to take the curvature of Earth into account.
Yeah, And
to keep those tubes straight because they're firing a bloody laser down it. So and of course that in a matter of seconds on Google you can pull up these as fitted drawings and it shows you the efforts they went to make sure that they kept the tubes straight whilst allowing for the curvature of the Earth, because it is each of these arms is so bloody long. I mean, usually in construction the curvature of the Earth doesn't matter.
No.
But when you start building things on a grand scale like this, you have to take account of it. And they don't like that. I think that's why there's so much butthurt and they come up with so much shit to try and argue against it. Because here you go, guys. Here's a construction that's so long they had to take account of the curvature of the Earth.
Yeah. Well, it's also what's different about this is because it's actually straight. If you were building a road 4 kilometres long, you'd put it, and if you said, okay, we're going to make it level, well, level's following the curve of the Earth, so you don't have to go to the effort. You just to get out there and measure the level as they go. But this actually had to be physically straight. It can't be, you can't have a bend in the tube. That's
it's like train tracks. They just follow the curvature and the terrain, don't they?
Yeah.
So what if the Earth's curve? And it doesn't affect train tracks because they're just following it anyway.
Yes. And the interesting thing I would say is that one test, which unfortunately you can't do, but would be great to do, if you stuck a water level on this, in theory, it won't come out level.
No.
Because it will all go towards the lowest point. So
I mean, that became pretty obvious early on in Blue's video that Mikey just didn't understand that LIGO is neither horizontal nor level.
No, that's right. It's straight.
Both arms are straight.
Yeah. I think it's even. Oh, hey, Blue.
Hey.
Can you guys hear Blue?
I heard a mumble.
I don't know if they. Oh, can you?
Yeah, I can hear you. Yeah, here he is.
Okay.
There you go.
I'm having to do it from Discord because Zoom is acting like a pain.
Yeah, it's okay.
Yeah,
I've got my audio filling out to Discord so they can hear what I hear you hear. So so as you probably gathered, we're talking about LIGO. Did you see the Google Earth stuff I did?
Yeah, I saw a little bit of it.
Yeah, I was just saying how that. Sorry, just transition this back for the others. And yeah, because that was just getting exactly the same shape, but when you look at it it's flat and straight. Yeah, that's what we're just at that point we were saying. The thing that would be really interesting is if you could do a water level test on this, because obviously the water's not going to sit flat, even though it's.
Well, yeah, they're not level.
Yeah. So it's something that's straight that isn't level.
In fact, by definition, not level. Definitionally, there's an elevation change. It cannot be level.
If you like, I'll send you this KML file. I don't know if it might be useful in other debates. You can bring it. You have Google Earth, I assume, somewhere.
Yeah, sure.
You should be allowed to. That might be useful. But yeah, that was it. It was a fun little exercise, although I hated typing in the 270 odd levels. That was a bit of a pain, but once I got through that.
Yeah, it takes a while to put all that data in. I know.
Yeah.
Mike is just an idiot. What else can you say?
It was just weird, though. The sort of end of it was like, what was the bit about the slope between the two? What difference does that make to anything? The slope between, if you went across here, draw a line. So if you went from there to there, what difference has that got to do with anything?
He seemed shocked and amazed that if you have a 4-foot elevation change in one arm and then an additional 4-foot change in the other arm, that from the beginning to the end, there would be 8 feet of elevation change.
Yeah.
Why was that amazing?
Yeah.
And I'm sure he thinks
I don't quite. understand that.
I'm sure he thinks it's a straight slope too, but it's not. As far as slope goes, it's not a slope.
No, that's just the change in elevation. It's not linear. The elevation points are not collinear. When you plot them as elevations, they're not.
Yeah.
No.
I just found it so interesting because it's that when you look at this in profile on a plane, which is basically how this profile's done, you would think, oh, that shape's just not right. So, but it is just when you pull it in, you can see that that's exactly where it needs to be. It's great.
I mean, the very fact that he kept on spouting off y equals mx plus b. I mean, like y equals mx plus b only applies to a Cartesian coordinate system, which clearly LIGO is not using.
Yeah.
I even asked him at one point in a thread that was going on what b was in his formula. I said, y is equal to mx plus b. Okay, Mike, that's a straight line. Can you tell me what b is? He had no idea what b was.
Yeah, and where's the origin of that coordinate system?
Exactly.
I thought for a sec he was going to say that was how he worked out the slope.
I finally said, Mike, B is what we call the y-intercept. That's why we call this the y-intercept formula. Jesus. I don't think he knew what M was.
No.
No, it's just a formula he's rattling off.
Yeah, he's just parroting bullshit he's heard. And he seemed all proud of himself that he knew the Pythagorean theorem.
Well, that's the kind of shit you go through in grade 8 at school.
Yeah, it's pretty basic, isn't
it? Yeah.
Cherry views Pythagoras. Okay. Well,
yeah.
What else are you going to use? Something else was going to Yes, even though
we can use Pythagoras, but I'm not sure why the distance, the hypotenuse is of interest to you in the first place.
No, I don't get it.
Who really cares?
Is he going to try and argue that the slope here is different than this slope there? I don't know. Unless they're trying to use that ridiculous, if you start at one point and you go 90 degrees and you curve, you end up with a point level that's different. It's like, I don't know. Who knows what they're thinking?
Exactly. Who knows what they're on about?
Interesting thing is, when I was keying up things to look for to talk about tonight, just in case, I went into Bev's channel to.
Oh no.
Not into his channel, just into his YouTube, right? So this was the last YouTube I could find. Now, you know what usually happens with Bev? Hang on, sorry. I'll do that so you guys can see. Why is that not that? Nope, that's not the right one. Oh, I see what I did. There we go.
You just have to take it on.
Look at the times, how much time there was. 21 minutes. I don't think anyone turned up. I mean, yes, there's some people.
Sometimes does this. He'll stream for about half an hour and then they'll carry on in Discord.
Okay.
Oh, he did one yesterday though that went on for what? 4.5 hours, 4 hours.
Oh, did he? Yeah.
This is the day before.
Yeah. Well, the first, it takes up till about here before he even gets into talking about anything.
Yeah. That one's 21 minutes, and he must have asked 15 times in that 21 minutes. Does anybody have anything they want to talk about? And nobody said a word.
Because he gets to here and he starts dissing out on.
Accept it as the word.
Sorry, start dissing out on Rumpet, of course. But anyway.
Word. But there's a difference between old words that have been taken out of usage because, I don't know. Just because they're not popular anymore, maybe a little bit. they're used to explain certain things that it's a bit uncomfy to talk about. But what we've been
Is level uncomfortable for us to talk about? I don't know.
It's for them.
It's for them.
told
I
off
think.
about recently, or not say told off, but we've noticed that there are people commenting on the fact that we are defining things that don't seem to have a name or a definite. Well, they have a definition, right? That there is a use for them, so they have to be defined. Now, defining these things correctly is the use of definitions, right? So you can say with a definition.
That's very profound, isn't it? Defining something is the definition of definitions.
Yeah, usually there's no one single definition for a word. Have you noticed that when you look up in a dictionary, there are usually multiple examples of how the word can be used?
Yes, particularly the word level.
Kind of hard to find.
Yeah.
It's hard to find a word that that only has one definition, really.
Exactly. Yeah.
So you say something that it's similar to, and then you say what the difference is. For instance, the rumpus pole. Now, the rumpus pole is a new concept, but it is the difference, the calculated difference between
It's a figment of your imagination,
and
Bill.
level.
It is,
Yeah.
yes,
Yeah.
exactly.
Rumpus
Really,
pole
it's the difference between
Who's
two.
made it up?
Yeah, it's not something magic. It's just you try and have a go.
He always refers to the singular as if there's only one target in Rumpus's experiment or whatever you want to call it. There isn't one. I think I've lost count myself now. I think there's either 4 or 5. That just happened to be the tallest one at the end, the one that we were putting up, the one that I took that bloody photo off. I really wish I hadn't now, but there you go.
Yes. Do you regret it? Yes.
Two horizontals. It's the equipotential surface at one place when the angle measured to the other place. But this is particularly the.
Can anyone explain to me what equipotential surface is? Got me.
That would be a two-dimensional surface that has the same gravitational field value at every point along its surface, right?
Would have to be, wouldn't it?
Yeah, that's what he's
Yeah.
trying to say.
Yeah.
Opposite
It's a global
side
thing.
angle.
It's not specific to any one location. It's something that applies over a large area. Whereas
Yeah.
horizontal, on the other hand, is only unique at a particular point.
Yes. Lost again.
Opposite
It's
side.
literally every point on that surface at the same gravitational potential.
Yeah.
That's
Yeah.
what it means.
So I think it's got a hold of that and just likes to use it.
Side to the angle of equipotential. And that's the rumpus pole.
Now wait a minute.
It's
That's where he goes all goofy. The angle of equipotential. What the hell is that?
Yeah, what does that mean?
Yes.
separates.
That sounds like
the two
something Magnetic Festa would say.
Yeah.
Gets onto some other stuff.
and that's the rumpus pole. It separates the two horizontals. Now, there's a bit of a bone of contention whether it's perpendicular at the base horizontal or perpendicular at the elevated horizontal, the one that isn't the base.
There you go. Have you heard that one before?
No.
Contention by who? About what? That there's different horizontals, different point. I don't know.
Rumpus will be making it very clear within his video. But there is a bone of contention, obviously, because Mick West has labelled surface level a straight line, and therefore there's nowhere to place the rumpus pole. Just not possible. And rumpus has gone missing, of course. He'll be putting finished touch into his videos. We're going to have there is some help. There is some help coming for rumpus, but I'm not too sure whether he'll accept it, since he is the head globe mathematician.
There you go.
What?
You've been demoted.
He just can't stop making shit up, can he? He lives in his own little fantasy world.
He does, doesn't he?
I can't keep doing this. Has anybody got anything else to do? This is.
Yes, this is boring. I think he gives up then. Pretty much. Well, yes, I thought that was. So his next one was much longer than it. That was just the one I picked up. Yes, I suppose it could be worse. I was
Yeah, it could be raining.
It could be raining. Well, I could play CC.
No, he does occasionally do that. He'll do a very short YouTube thing and basically say, we're carrying this on in Discord, and then sometimes he'll go on for 4 or 5 hours, and in those 4 or 5 hours he'll say basically nothing, particularly nothing that you haven't heard before.
No.
Well, that's what he did yesterday. He took my 12-minute video and spent, 3.5 hours going over a 12-minute video.
So I didn't see that one. I was looking through videos before. So he actually did stuff on your video yesterday.
Yeah. Go to his channel. Go to live.
Let's
I
see.
guess it's on there.
Let's see. Find where is he? There he is. Let's go down to his. Oh, there's 3 people in his thing. Be under YouTube's, wouldn't it, or just in live? Let's see.
Yeah, go to YouTube. Yeah, go to his YouTube channel.
We'll go down the bottom. I imagine it's got to be near the bottom. Playing 4D. Yeah, the playing 4D chess with Mike. So that sounds like it, doesn't it?
That's it.
Let's do this one. Hang on. Let's see. I'll just switch this over. I'm guessing I can skip through a lot of the start. Nothing happening.
Yeah, just get up to the point where you see my video come up.
Yeah. Oh, that looks like it there, doesn't it? There we go.
Yeah, somewhere back in there.
This argument's been planned for quite a while, and this responses from Blue is absolutely amazing. We all need to applaud Blue Marble Science for this. So let's give Blue Marble Science another view on his thing. I'll get the link.
How long does it take to go through it?
How long is the stream? 4 hours?
Blue Marble Science.
No, I meant to actually play it.
Hello,
I'm just watching
everybody.
it.
You know, they say never play chess with a pigeon because the pigeon will just knock all the pieces over, crap on the board, and then fly back to its flock to claim victory.
I was asking that.
Oh, he got.
Who does say that?
10 seconds in.
What a weird analogy.
I know. Who does?
Sorry, he got, what, 30 seconds in before he could pause it. Who says he's never heard that before? Obviously, doesn't get about much, does he?
Of course, he's heard it before. It's all part of the act.
You reckon?
Yeah.
Yeah. Okay.
Yeah.
Play chess with pigeons. I mean, surely playing chess. There's other places to play chess. But who talks about playing chess with pigeons? It's really weird. And I don't know whether it's some sort of an analogy or anything, or whether it's just like one of Blue's.
Is it some sort of analogy? Yes.
It's a metaphor.
Exactly.
Weird stories. I noticed he's got rid of Gladys, though. Pigeon instead.
A while back over on Red Rhetoric's channel, I got into a bit of a pigeon chess match with a flat earther that calls himself Mike Jones.
Now, like I say, Mike isn't a flat earther, but Blue Marble Science does like to do this. Mike can come back and point out for himself whether he is.
He's a flat earther just like you are, Ben.
But I noticed that Blue Marble's quite keen to categorise people in this manner. I don't think it's fair. Shouldn't really be done.
No.
Sort of an ad hom. But I don't know. Modern day ad homs, I don't know whether that's acceptable.
Are you?
Yeah.
Are you butthurt there, Bev?
MJ, you chose that name, so that's what we will call
Poor
you.
little
Here.
sausage.
So let's do a mic check first.
Yeah.
Mic check, please.
Gentlemen.
Okay, everyone can hear him.
Yeah, I can hear. Fine.
It's a true mic check, that.
So, Astronomy Live, Big Blue, you are free to stay. Same with you, Slice Arcane. Piece of shit. So, all right, MJ.
So, I know we've been over this, but it is worth pointing out once again. Red's Rhetoric, Astronomy Live, Big Blue, Blue Marble Science, and Slice Arcane. I think Mike Jones did very well getting on here. This is a rather exclusive group of people.
Yeah,
I
I don't think
So
so.
we were chatting this morning, and you said that
Yeah,
level
we
isn't
can get
horizontal,
on
and
to
you could
asking,
prove it.
really?
I was just curious how you plan to prove it.
When did I say that and where?
No, it's a little blue. Not talking to you.
So there's the claim from Mike. Blue, you say that level isn't horizontal. How do you intend to prove it? Fair enough.
No, you want to know when I plan to prove it.
Yeah.
You haven't watched any of the videos that I provided.
Okay, you haven't watched any of the videos I provided. Is there a proof in one of Blue's videos for level
I wonder it
not
takes them
being
so long to go
horizontal?
through a video. Bloody hell.
If there is, it should be titled "Proof of Horizontal Diverging from Level" or whatever.
Mm-hmm. Yeah,
But,
I'm hoping so.
there is no.
And enter the stuttering nitwit paper.
Yeah.
Such thing, I think.
Well, he has done a few that are called level is horizontal or something like that. There's, there's quite there's videos out there.
Yes, okay, I know that he made some videos about a topic, but Mike Jones is asking about proof, not about something about. That's the difference.
But this is Blue Marble Science proof, new science. Before, we've heard that they don't have any proof. Well, necessity, that's why I called this 4D chess. We've been developing an argument and simplifying it, advanced simplicity, and now we've got an argument ready. We're after engagement to have this conversation. Now, these arguments have been developed to help prove the globe. So what we've been doing, obviously, we're not flat earthers. We've been helping generate this.
Right. Okay.
I don't know what to call it. Call it publicity. Well, why not? And Blue Marble Science is helping us
Question Beveridge
push
uses to
this
answer.
new proof of globe.
What is the shape?
It's a slightly new. We call it Globgic, but that's what we're here to do. We have, obviously, we've built up the rhetoric, and we now have the ability to put forward these arguments for proof of globe. The real globe, the dogmatic globe, whichever one you want, either of them. Mike Jones in the YouTube chat, he's definitely not a flat earther. So Blue Marble Science has already ad homed and misrepresented Mike Jones right at the beginning. I think that's a bit dishonest, but as you'll learn, this is the new Blue Marble Science tactics. And it's one of the ways that you engage with people nowadays in this modern scientific pitter-patter or whatever, So it's like just a cheerful, a joking, sort of friendly banter. Because Mike Jones, as you'll see, he gives the ability for Blue
Mike Jones, friendly banter.
Marble to explain. Let's go.
Well, we were discussing this morning pouring concrete, and you said we could definitely level it. And then you said it's definitely been made horizontal. And all I asked was, in your 100+ years of construction experience, how did you determine it was different from level? And how did they do it? And what was the process for making it horizontal?
You notice, you notice Bev allowed Mike's weak attempt at an ad hom just to slide right by.
Oh yeah. Yes.
There's Mike trying to insult me by saying your 100+ years of construction experience. God almighty. Just call me an old guy, Mike, and get it over with. Jesus Christ.
That's the friendly banter. Haven't you worked that out?
Yeah, well, I was condemned for calling him a flat earther, but he can say shit like that.
Yeah, that's what I mean. Yeah.
No double standard here. No.
The idea of horizontal with concrete ever became important. Yeah.
Here we go. He only knows of one case where concrete being horizontal is important. Only one.
Replay it. Yeah.
I'll put it back again.
Replay it. I might say something different if you replay it. You never know.
Yeah, we'll try it again.
Mike, I only know of a case where the idea of horizontal with concrete ever became important. Yeah.
Here we go.
That's
only knows of one case where level, concrete being horizontal was important. Only one. I'll put it back again, just so you make sure you don't want to miss any of this. You've got to
Here
get
comes three.
this argument from the base.
Even then, he got it wrong. I mean, you said that you only know of one case where horizontal with concrete is important.
You know?
Yeah,
Only
he
was one
said-
case
You
where
said that concrete being horizontal is important. Now, they're two different things.
Yeah.
Yeah, it got a little twisted, didn't it?
Yep.
Yeah, absolutely. Deliberately, I'd say.
Yes.
I think so.
concrete being horizontal was important.
No, he didn't say that. He said ideal horizontal. And this is...
Ideal?
Yeah, good.
Yes, he said ideal horizontal.
Let me go back again.
Go back again.
The idea of horizontal.
I think he says the idea of horizontal, doesn't he?
Idea?
There's
The
four.
idea
I
of
misheard
horizontal.
because I heard like ideal horizontal. Maybe
Let's
I'm
go
mistaken.
again. We'll do
I
it.
don't think so. What was the process for making it horizontal?
Mike, I only know of one case where the idea of horizontal with concrete ever became important.
The idea of horizontal
five.
with concrete
okay.
ever became important. Only one case.
Plus the repeating what you said
Not
afterwards.
like knowing where they, like you have a grade or whatever for
Yeah.
drainage, right? You would say that horizontal being a zero slope, it would be pretty necessary, I would have thought. Any concrete, not just the one time.
No.
I would say that this is not about idea because if someone is
What if
making
they have
concrete,
side,
it means
side
that
slope?
it is based on
drainage isn't
some
important.
measurements, surveying, something like that. And this surveying is based on rather definition of horizontal, not idea of horizontal. You can have different ideas on horizontals, but definition used in practice, in surveying practice is one. That's horizontal is straight line perpendicular to vertical. So why he's talking about some idea? This is not about idea of horizontal.
What the
I don't know.
was that meant to mean?
Yeah, it does seem a little bit strange, but this is blue. And he's saying, like, he's building it up, I think. There's only one place where that you could actually, maybe that's what he means. There's only one place you could go to argue or to, if you want to talk about concrete being horizontal, there's only one place that you could go to for this discussion. And that's LIGO. That makes sense. Two straight arms, horizontal straight. So here we go.
And
They're
that
just
would be
straight.
LIGO, or maybe some of the other parameters.
And you have 100 years of experience, so surely you've spoken to the contractors who made it horizontal.
100+ years of construction experience.
Yeah, so Blue Marble Science there and his 100+ years of construction experience. He's very, he's been around, Blue Marble Science.
Let's just repeat it again.
He's an engineer. So if anyone would know about these sort of things, it's Blue Marble Science.
You're a
It's
funny
not
guy. Mike.
Bev. I do know.
Are you talking about LIGO? No, I haven't spoken with contractors. I've gone by the.
So it might not be horizontal. So the concrete foundation might not be horizontal.
For those that might not be familiar with it, LIGO is the acronym for Laser Interferometer Gravitational Wave Observatory.
Oh, there you go. You want to
Wow.
hear that again? You want to hear that again? For
Yeah,
those
yeah,
who-
that was
For
impressive.
those who aren't familiar, he practiced that one, didn't he? He's got it
Yeah,
scripted,
yeah.
he's got it wrote out in his script, but he practiced this.
So the concrete foundation might not be horizontal.
For those that might not be familiar with it, LIGO is the acronym for Laser Interferometer Gravitational Wave Observatory.
He misses the W, right? Because like
What a nuts.
doesn't really understand.
No, you look it up.
Sounds like a commercial.
They hyphenate
The wave.
gravitation,
They missed
the
out.
gravitational
It's
wave.
straight.
Yeah,
It's
that's right.
hyphenate. It's all one.
He didn't miss the W. It's not in the acronym.
Not
It's-
called LIGO.
The sucker LIGO. Yeah, that's right. It's
Yeah.
LIGO.
Lines really, isn't it?
When you see them write it out, they spell out
when
gravitational
you-
and then
because we're
hyphen
debunkers now.
wave.
When you look at this, can you see that?
That's why the W's
mirrors.
not there.
Yeah.
Let me just get rid of the Discord. Where's it gone?
Flipping idiots.
Yeah.
Oh.
Come on.
The laser comes from the laser, and that laser comes through a power recycling mirror. Through a power recycling mirror, or a few of them, perhaps. And then it hits the one that's tilted at 45 degrees. Actually, no, a bit of it goes through the one that's tilted. It's partially... Oh, no, that's a beam splitter, sorry. The beam splitter, it goes through
Sorry.
on this side of it, obviously. This side.
Sorry, I can't listen to Bev trying to explain science. Let's skip forward a little bit.
It's funny. Yeah, it's funny.
Yeah.
It is.
Well, let's
He
go for a
messes
little
it
bit.
all up.
We'll go for a bit. Okay.
Side of this mirror must be the partially reflective one. So it goes through that, hits this mirror here, and doesn't come straight back up the mirror. It moves over to the side a bit, obviously, because it needs to go back through.
You mean the
No, it
diagram
needs to keep bouncing.
moves to the side, so you
I think
can follow it.
bouncing through because it keeps bouncing anyway, and then it goes back. The detector. I don't know. It doesn't. It's hard for me to work that out. How does the laser go through a mirror, bounce, and then come back again on a different side and go through the
goes
mirror
up
as
to
well?
the
Isn't it
other-
meant to bounce? It
It
only...
goes up.
Oh, it's
doesn't
this one's a full reflective mirror, so it does bounce at these end ones. It bounces back again.
The clue's in
On
the
the
partially reflective mirror, Bev.
I don't know what this dotted line represents, really.
The path of the light.
The dotted one's the return path.
So it is not returning just bounced off. It's doing something else.
Well, this isn't like, this is a simplified.
Yeah, but how does it manage to go through a mirror and then bounce off the mirror to come back again? Because they do bounce backwards and forwards, don't they?
That's what the
As a matter of fact,
Go ahead.
Can you read the labels? Can you read
no,
labels?
is that you, Buster? So do you, bro. So feel free.
It's Mobius.
Mobius, but
Oh, Mobius. I mean, sorry, Mobius. Why do I always do that? I should slap myself. Sorry.
Yeah, you should.
Yeah, okay, I'll
really
be short.
hard,
It's called the
actually.
Perot cavity, and with the laser bounces 300 times a second back and forth. So
300
it has to
times
be
a second.
accurate. That system has to be accurate to, if I'm not mistaken, 1/100th of a proton, something like that. Something ridiculous, unimaginable.
How does it bounce? Go through the mirror though? What's this partially reflected mirror? Like, what's that about?
Yeah, that's a 50% coated mirror, so it allows some of the light to pass, and some of the light to reflect, if I remember it correctly.
Well, yes.
Okay.
It's not that hard.
And it's
to
that bit of the
work out.
light that does get through.
I mean, that says something.
is the
If
stuff
Bev
that can
can't
bounce.
understand it, but SE does. And we know how dumb SE is, I mean.
Yes, that's right. Yes. At least SE can read that it says partially reflective.
Yeah.
Which means
Yeah.
it's partially reflective.
Yeah, I think it splits first. I haven't looked at it in a while, so I think it starts off at one, and then it splits through that half mirror, and then it goes down the two beams, and it bounces back and forth through the Perot cavities 300 times, and then it goes back again, where they can see if it interferes or not.
But then it has to go back through the reflective mirror, the partially reflective mirror. Like
I believe so, yeah.
So after the bouncing 300 times, something happens to the mirror to allow it to pass through the mirror after it's bounced.
Nah.
Like one way, it has to be able to pass through a mirror to get into the beam to go backwards and forwards and bounce. But then it has to be allowed to go back through the mirror and not bounce at some point after a maximum amount of bounces, or like I don't know.
It's fucking magic, Bev.
You don't know.
It's part of the story, yeah.
Magic.
I don't claim to be an expert. Yeah. It sounds like fantastic, but yeah, that's how they explain it more or less.
I don't think it's that
And
complicated.
now the
is it?
idea of that thing being 4 foot or 8 foot, like Blue says on either end, that's absolutely ridiculous. Absolutely ridiculous if you understand how the mirrors work and all that. Yeah, there's no way.
No, but it's a proof of globe. It's a proof that it has to be a globe, right? Because when
mirrors
we
aren't
have the
4 foot.
understanding of level being horizontal and these arms being straight lines, I mean, forget about the difficulties of getting lasers to pass through mirrors, but then bounce on them and then pass through the same mirror that they've bounced on.
Yeah.
Forget about that.
Mobius did a good thing on that.
Yeah.
Mobius did a very good thing on that. Yeah. Check it out on his site. And tell us about that arm, the one with the concrete. That was good, that one.
Well, we get there to this. Have you seen this one of Blue's? This latest one?
I've seen this video. Yeah.
We've had a few views.
So let's carry it on, because have you seen it, the one with Blue talking? Because Blue's
Yeah,
done
one
the
that
talk over it.
with red. With reds. Yeah, I seen it. Yeah.
Because he has just replaced, he's just done it recently.
He
over the
just
last couple
asked
of
the
days with his
question
little voiceover.
and answered
That's
it.
what this bit is now, where he's talking about LIGO.
Yeah, Blue posted it and he was bragging
That's
about it.
asked 5 times yet.
Oh dear. Sorry, I'll skip through until it gets to. Here we go. Got to be something here.
Count for Earth curvature. So that's what we're talking about.
The pads of LIGO having to be adjusted for Earth curvature.
Yes.
Okay, got it?
Otherwise, we wouldn't be talking about it.
Yep.
If you say so.
Time and time again that none of the pads at LIGO are technically horizontal.
None of the pads at LIGO are technically horizontal. Go over it again. Blue marble science.
So that's what we're talking about.
Right. I have assured you time and time again that none of the pads at LIGO are technically horizontal.
Technically horizontal. Anybody know what that means?
Means
It'll be an engineering term, right? Technically horizontal.
I don't know how long ago Blue retired, but he did used to say that the tubes are horizontal.
Mm-hmm.
Did you ever say that, Blue?
Nope.
I don't think so. I'm sure you would have said that was straight, but not horizontal.
That's straight.
Yeah, but he's talking about technically horizontal.
And since I think straight is horizontal, therefore you said they were horizontal. So maybe.
See, that technically horizontal might be different than horizontal.
Maybe.
Not that horizontal.
Not that horizontal, yeah.
No,
Are they level?
No.
Are they straight?
Not level either. Not horizontal. Not technically horizontal. Not level.
Are they straight?
Are you going to let him answer?
These guys always want to talk about level and horizontal. They think the two.
Now, can you see that? What do you reckon to that?
There is number of propositions. Okay. So not proven.
How many?
No, first, verticals are radial lines. So
it's
this
fine.
is first, yeah, so
5 laws of globe. They not look familiar.
Yeah, this is just the story. Yes. So
these are the 5 laws of globe.
Are these the Rumpinian laws?
Rumpus and
yeah,
I think, or they may be like an adjustment. Blue may have maybe rewrote them a bit. Some of the bits that he wasn't happy with. These are the 5. Verticals. These are like the when Blue Buster just recently been talking about with the rule book. Everybody has to go into conversation with a rule book of their preconceived rules. Everybody has them. When we talk about the model, this is what you talk about, the rule book that people go in with. And these are the rules that have been wrote down by Blue. These are Blue's rules that he's telling everybody. These are the rules he's living by in order to get his globe proof.
Yes, thanks, Blue, for making it up. We would have been lost without you. Well, until we looked up any other book that said the same thing. But anyway.
Yeah, but the fact that it appears in every damn surveying book ever published.
Well, yeah.
Not exactly hard to find.
No, the concepts aren't difficult. But anyway.
They go over these things and they over and over and over.
We've heard those
it's ridiculous.
Before. I'm going to skip forward a little bit.
Yeah, you can skip past a lot of that if you want to.
Yeah. Let's see
point of tangency. Yes. Yeah. Very, very scientific.
Yeah. It's the horizontal line that is just a point that exists within this dogmatic globe model. Blue Marble's going to prove it.
So level and horizontal have 2 very different meanings.
2 very different meanings. And equal elevation, I would say. I wouldn't say that's very different.
It is very. We've heard that before. Come on. Something new.
Look at the plane.
Yeah.
And look at the point that it's tangent to.
How could that be? Which point is it?
Does it
it's
look
3
like
point. No.
A little red point here.
It's only one point.
The picture doesn't show this properly, so
it doesn't look right, does it? There's like I don't know, about here somewhere.
Yeah,
For me, you know, like I don't know, it's hard to tell, isn't it? You know, somewhere around here somewhere, but not here. Maybe here, somewhere around there somewhere.
Yes, because in this
the fact that he's even saying, "Oh, it should be over there," shows that he knows what a tangent is.
Like perspective view, this plane is above the ball, so it has to be the highest point in this picture of the ball.
No, it doesn't.
But what he's marking, it is not.
Jesus Christ!
So for me, that's strange picture.
Also, the plane seems a bit off.
It's just a sketch, just a cartoon.
Yeah.
But
just an image.
Draw the diagonals in there and see where they cross. And it's right about the point where
I wouldn't put it there myself, but maybe it's just an angle, whatever. But the whole thing looks off.
Yeah, that's the point I'm trying to get across, right? If you're looking at that and thinking, That doesn't look right.
Yes, perspective is weird here.
It's just something wrong with it. The whole thing just looks
perspective.
wrong.
Yes, off.
This, I'd say, is metabunk. Blue Marble Science is metabunking this for you. For you to be able to debunk it and say, that looks like there's a little bit of nonsense there. Whether Blue doesn't understand where
Just
a
a
tangent
part
is,
time,
or,
Bev.
doesn't
Play the
understand
rest
what a
of it. You'll
tangent
find
is,
out what I
just looks
said.
a little bit wrong.
Yeah.
It just does. Can't get away from that.
A particular elevation at that point. The two arms form a triangle, and that tangent point lies somewhere within that triangle, like that.
Okay,
Yes.
like that. The tangent point lies within that triangle somewhere, says Blue Marble. Has he helped himself out a bit?
No, it says LIGO.
Could the tangent point
Yes.
possibly lie within that triangle somewhere?
I don't see that in this picture. So
What else do we see? Metabunk. Sorry, let's debunk. Anybody see anything else that looks a little bit strange?
Well,
You ever
the
talk to
corner of
Blue
the
Marble about
triangle
this?
is
Might
within
see
the
it.
triangle too, you know, Bev.
It is, yeah.
It is.
Say what you see. Come on.
this northwest and southwest.
Okay, now they are directions.
Yes, they are triangle arms, so they are not perpendicular.
So what would northwest be, and what would southwest be?
They're just the names they gave to the arms. But anyway.
On the compass?
Let's see where they go with this.
Northwest arm and the southwest arm. Those arms are perpendicular to each other, right?
Could be.
Yeah.
Okay, now, is northwest and southwest perpendicular to each other?
No.
Yes. What an idiot.
Yes, in all drawings, yes, they are. On any map.
It
or
is
whatever.
on my globe. I don't know.
Northwest
It
and
is,
southwest. East.
Let me get my compass out. I'll check, Bev. I'm
can't-
pretty sure
Bev
they're
can't-
perpendicular.
East and
Bev
north.
can't be
That would
wrong.
be
Come on.
perpendicular.
Yeah.
Southwest, northwest?
Draw it
Yes.
out, Bev.
Yes, should be.
Let's go along with that then.
You can tell he's realised that they're telling me that I'm wrong. Ooh, maybe I was
And only
going to go.
Bev could make such a drama out of such a minor thing like that. I mean,
And then you realise, ooh.
Yeah, let's see, Bev. 270 plus 45 minus 270 minus 45 is how much? Oh, 90. I got it. Yeah. Okay. Yeah, they're perpendicular.
And if that's the northwest line and that's the southwest, sorry, if that's the northwest line, that's southwest. Where's north?
So the northwest arms and the southwest arms meet at a point. Somewhere within that triangle is the tangent point. Blue Marble's explaining this.
Yeah.
You
So
are.
obviously, since that plane is only touching that spherical elevation at one point, as you move away from that point, the distance from the plane down to that same elevation is increasing. And it increases at the rate of about 8 inches times the distance you are from the tangent point in miles squared.
Right, so what we know is that LIGO lies within a plane that is tangent at some point. But one of the rules was that... Go back.
rules.
Tangent planes associated with the same vertical but at differing elevations are parallel. Each vertical can have one and only tangent plane for a given elevation.
Yeah. And?
Right, so LIGO lies within a plane and each vertical can have one and only one tangent plane for a given elevation.
Yes.
And we've got one tangent plane that LIGO lies in.
Yep.
That spherical elevation at one point.
And?
As you move away from that point, the distance from the plane down to that same elevation is increasing. And it increases at the rate of about 8 inches times the distance you are from the tangent point in miles squared. Here's the actual elevations at LIGO.
So he's describing same elevation with this robot arms calculation. So he's calling this 8 inches per mile squared equal elevation.
He said one tangent plane, right? LIGO lies within one tangent plane.
Yes.
Yes.
And there's only one tangent plane for each vertical elevation.
Yeah.
And here's the elevation. There's 3 different elevations, so... Anybody...
That's more than 3 different elevations, but okay. They're just the ones you've shown.
There's a whole bunch of different elevations there, but the tangent plane is set at the elevation of 529 feet.
I'm really not sure if he's talking about equal elevation due to curved level or due to this horizontal plane.
Yeah, it's a tangential plane, right? Or what you called a tangential plane, but call it horizontal plane if you want.
I don't think you used the term equal elevation at all, did you, Blue? I don't think you had that in there at all.
No, I didn't.
No.
Horizontal at some point, somewhere in that thing, but it's only a horizontal plane at 1 elevation. Yet you've got 3 different elevations.
Yeah. Mm-hmm. And?
So which tangential plane for which elevation are we talking about?
He's thinking earthworks. We won't give the ball away, but you know what I mean, Bev.
Well, you find the top. Look, this one here is 537 feet. This one's here, 529 feet. And this one here, 533 feet. So, quick test. Where's the highest?
537, of course.
Biggest number.
Yeah.
So this would be classed as the top, the highest point.
Yep.
These ones are classed as below this one. This is 4 foot below, and this is 8 foot below. This one here is 4 foot below this one, and this one here is 8 foot below that one.
Okay, so if he's talking about drop,
elevation,
so it means that this highest vertex should be this original tangent, I think. I'm not sure, but I think that would be logical, let's say, for the sake of argument. Almost logical.
If horizontal planes, well, I'll let Blue go over it, because obviously we have to go back over this a few times.
Oh, well, yes, of course.
The Kumu virus said the lowest one would be the tangent point he's talking about.
Oh, would it?
Well, that would make the... How could you have the lowest one? The tangent. That would make this higher.
Oh, God.
If it is a drop.
Yeah, that is a drop. That's a lower elevation. So you have to go down from the highest point. Surely.
Yes, if you are measuring from horizontal plane, this tangent horizontal plane, and this is really plane, so that would be drop from that horizontal.
Tornagon says that the different elevations are referenced to the globe.
Told you, earthworks.
No. It cannot be. Not so easy, because on the globe model, this level, so equal elevation means globe already. So you cannot have drop from globe, because it is equal elevation. So there would be no drop. This is inconsistent.
Are you trying to think logically?
It is an elevation.
You're asking that. No, it's not.
Hyperorganists think logically? Never.
This is way too complex for them to work out. Just, yeah. They won't get it, ever. I don't think.
Change. Nobody's going to say that a varying vertical. It's an extension of the vertical to give you an extra elevation height. Definitely, that's how you measure elevation changes. So the one that is 537 is the longest, the highest of all of these points, because it's got more feet. Makes sense.
Did he basically just said that's the highest because it's the bigger number? Basically, it's got more feet.
If you are level at one point and go out remaining horizontal with that point, the ground would drop from you or you would rise. Same thing.
But still, the problem is if Blue Marble is calculating from curved level or from this tangential plane. We don't know.
They keep forgetting that you've got to have a straight line. That's what we're trying to achieve. No concept.
So I would say if they were on equal elevation due to their curved level, as depicted by Blue Marble science, so if they have equal elevation, it means that they would have the same numbers, because on curved level it is equal elevation.
Well, all you have to be able to do is say, from the highest point, if you put a horizontal...
Sorry, I'm skipping forward. It's just...
Be great. That would be the first globe solid proof.
Yeah.
Yeah, what do they say now?
Yeah. If Red's Rhetoric could give us how it's clearly, and also the evidence for his claim about my family, that'd be nice if he could just do that. And obviously, I think this is why Blue Marble has posted this video. Because Blue Marble is hoping for a bit of help from Red's Rhetoric, because Red's Rhetoric's in this video, saying quite clearly this elevation changes of 8 foot. One arm from the apex, one arm going up 4 foot, the other arm going down 4 foot. That's quite clearly affected by the curvature of the Earth, apparently. Affected by the slope of the land that they're putting on. I can't imagine why they haven't built it straight, on a plane.
They did.
Because didn't he say that it was a horizontal plane? Or only horizontal?
No, he said it was straight. Come on. Did they say anything? Sorry, it's awfully long, so I'm going to try and... Let's get to see what he says about when you get to this point.
Are they straight lines?
No. Well, they are, but...
Are the LIGO arms straight?
Supposedly, yes.
Okay, well, let's listen to this again. Listen to Blue.
We could have looked at the actual elevations of the LIGO pad that those tubes are sitting on. That's not a straight line.
It's not a straight line. So you thought, right, that the lasers and all of that, you thought that they were straight, the straightest things in the universe. Remember how it started? That Mike asked him about pouring concrete, and Blue said the only place where horizontal has been important was LIGO. And now he's saying that these are the actual elevations. And it's not a straight.
Yes.
Trick of the eye.
Yes,
Bill,
those are the actual elevations. that is graphic proof that you cannot draw a quote unquote straight line on the surface of a damn sphere. That's what that's showing you.
No concept.
The line is going to curve.
Yeah.
But not.
Nope. Change in elevation, look. Pad elevation, feet. Change. Whoop. And it's not in like a linear change either, is it? Look.
It's curved.
Mike,
that's the point.
Mike says, did Blue forget that he and LIGO, it was LIGO that said, claimed that the delta between the surface of his dogmatic low model and the sloping horizontal tangent plane is a vertical elevation change.
Yes.
It's got it in this drawing here, look. See these lines here? Going up and down. Commonly called verticals. They're straight. This is the vertical change of elevation. Pad elevation in feet.
Oh, how many times are you going to say that?
In, the length of it. Yeah, you're right, Mike. It's an elevation change. So this, well, I'll go back and do that in a minute. Let's just finish the Blue off. He's telling us all about this.
Change to what?
I'll go back over again. Listen.
We could have looked at the actual elevations of the LIGO pad that those tubes are sitting on. That's not a straight line.
It's not a straight line.
But we could have done something really interesting. We could have plotted an inverse curve, an inverse version of that at the rate of 8 inches times distance in miles squared, and combine those two curves, and you get the perfectly straight line of the LIGO laser tube.
See? Nifty little bit of mathematics. Right, when you measure the elevations and find out it's not a straight line, then what you can do is you can plot an inverse of that measured elevation curve and come up with, hey presto, boom, a straight line.
So that would be an average of the straight line, average of two curves.
Like, it's not really, because when he's done the thing, if you look at it, it's not quite in the centre. There would be a little slight curve in this that he's not quite got right. I mean, maybe he's plotted it and he's plotted it on the wrong way around.
No.
Possibly.
Yes,
it's
but
fatter
still,
here and thinner
No,
here.
Bill, that's exactly the way it looks.
It is not a mirror, as should be. But still, the idea is good. But problem is that the idea is good to prove globe, of course. But still, problem is that averages don't exist in reality.
Ooh. Don't they?
So you have to choose. What?
What? What the hell?
averages don't exist in reality. Okay.
Oh, Jesus.
In
That's the
reality.
Virgin Mary said. Come again.
Yeah, well, let's give Blue points for sophisticated approach.
All right.
To solving a problem, right? He's just pointing out that the actual elevation profiles of a straight line is a curve, right? The actual elevate. I'll go back. I've got other drawings, right? But then, in order to solve that mentally, you plot an inverse. That's good, isn't it? That's good. Sophisticated points. I bet Humo virus is having that.
You've never heard of per inverse?
Combined elevation.
Obviously not.
Because obviously, once you measure your elevation, if you then plot an inverse curve. Oh, keep going. Yeah. Does that make sense?
For globe, yes, it does. Of course. Well, this is how globe can be proven.
The plotting an inverse curve.
Yeah, well, of course. Yeah. This is good globic, I would say. Good.
It's inventive, isn't it? It's inventive.
Yeah, of course.
Okay, right. So that is brilliant. So which are we saying, Blue? The actual elevation? Or are we going with the green line that's like a sloping straight line with an elevation change? Because this would be, the green line would be your traditional rise over run. Straight line gradient, wouldn't it? Grade.
And if you built that on a curve, what would happen? You'd get a curve.
That would be your run across there. And then that would be your rise, the elevation change, making the grade. But Blue Marble Science says that the blue one. I'll give you a little
blue one is real.
Well, the blue one's a measured one. That's what the actual measurements say.
Oh, and this orange or whatever color it is just mirror, let's say. Not exactly.
It's not a mirror.
Yeah, he's plotted it the wrong way around, doesn't he?
Yeah.
No, it's not plotted the wrong way around. You take each one of those points along the x-axis and root the two y values and average them, and you get that damn green line every time. I know because Excel is doing it. Yeah. I didn't make it up.
I think the other way that may have worked for him, I don't know. If you said that the orange line was the representation of the curve of the Earth, and the green line is if you take the elevation difference, you shows that the LIGO is going to end up being straight. But I don't know.
Yeah.
But I might not get that one either.
Yeah, I know that when you first stare at that curve, it looks like something's wrong. But now look at any particular elevation or any particular station, and go up to the two elevations, and look at what those are, and you'll see that the green line is absolutely the average of those two elevations.
Yeah.
At each point.
Well,
that's how I had. That's how I wrote that. That's how I did the spreadsheet.
Yes, I had thought of doing something similar in CAD. Is an elevation profile that has a curved datum to show that the LIGO line is straight, the datum is curved because it's to the Earth, and then the levels end up with this. I don't know if that will help anybody, but I doubt it. That's too complex for them. I think the shape, they have enough trouble with normal 3D shapes. This one's harder. Well, like it's simple, but it's hard for them to follow.
In straight line.
Yeah.
By mirroring this curved line. That's all.
It's not a mirror.
And yes, we have a result. Not perfect.
I didn't mirror it.
I think
that's not. It's not mirrored either.
No. Work on that. Perfect.
That is an 8 inch per mile. 8 inches times mile squared curve.
Yeah.
Over that distance.
They don't get that.
Beginning at.
Yeah, I was going to say they don't get that is you taking that point and running just that formula to end up with that curve, and then the green line is taking that value, subtracting that one, and that's where you end up with this one. Yeah, not a. Oh well.
This picture and with explanations, and that would be good globic proof for the globe.
Yeah, I think straightening this curve, the measured elevations. Let's see how he finishes off. Let's see how he wraps it up.
Hold on. Before you go, I just thought of something. Look, this is ingenious what they just did. Two curved lines. This is globic. Two curved line. Make a straight line.
Yeah, you just add in the inverse of the curved line in order to make it straight.
That's I call it average. Average of two mirrorings curved give you straight line.
That's it. Yeah.
Yes, but this is just not perfect picture. He should improve that because this curvature doesn't fit the mirror. So, but
That's because it's not a mirror.
It does fit. It's not a mirror, and it does fit.
That's the problem. You can't get it.
He's looking perpendicular to the green line, is what he's doing.
Yeah.
I guarantee you, that's what he's doing. He's imagining lines perpendicular to the green line, and then it looks like it looks like they're out of balance.
He's trying to say, this
But
one.
when you
That's the mirror
just
line.
take any vertical line then and look at it.
What's that line to that line?
Forget the rest of it.
Yeah, it's that point.
Because it's literally the formula. It's the blue line elevation plus the orange line calculated elevation divided by 2. That's what the green line is.
That's right.
I can pull up a spreadsheet and show it to you.
Yeah. Well, I know. As I said, I put this one in. I'm sure I did that little check to see whether if you did 8 inches per mile from the same points, did you come up with the same level? And they weren't perfect, but they're pretty close all the way through, which is what you'd expect.
Yeah, very close. Very, very close.
Yeah. I'm going to skip forward a little bit because, there's too many hours. I was curious to see what they say about the what Mikey said at the end. Did they get that far? It looks like they might have cut all that out.
No, it's back before this part.
No, at the end when you're... was it?
Yeah.
That's in here somewhere. Okay, let's see where's this back
I
here.
don't think it's that far.
Hang on, let's see where's what the...
Straight though, isn't it?
Yeah.
Well, there you go. Earth curve proved.
Compensation is needed at all shows that curvature is actually there.
There you go. This is Red's rhetoric. Such a good guy to have on team. I don't know how much we might have to do.
There obviously needs to be compensation for the curvature. The fact that compensation is needed at all shows that curvature is actually
Great, guys.
cool. Anyway, so you
must have missed it. Hang on.
It means that they making calculations make laser straight. So this is funny part of that. So.
Yeah. Yeah, and then what you do is you get your buddy, friend, Blue Marble Science, to prove that with a sloping horizontal plane. So here we go. Blue Marble Science is about to back up Red's rhetoric and his proof of curvature.
Correct.
When it was built, you're saying that it's built at some point. There's a quote center of that ball, top of that ball per se, and it slopes away from that point. And they've poured concrete in straight lines, one along A, one along B. What happens when they pour one along C? It drops 8 feet, Blue?
Yeah, it drops 8 feet. There's no
8 feet.
Drops 8 feet, confirmed by Blue, across the hypotenuse. That isn't there, but, you know, were you to imagine there was a hypotenuse there, Blue Marble states that at Hanford, 8-foot elevation change. On the horizontal plane, I think.
As per the elevations.
Thank you. It's been great, guys.
Cool. Anyway, so you...
Blue's laughing.
There's that laugh.
Yeah,
There's that laugh.
Nice. So, yeah, well done, Blue. That was good. So, Mike Jones, thank you very much, Mike. Arm number 1 of LIGO, up 4 feet to the apex. Arm number 2, from the apex out perpendicularly to the original arm that we've just gone up 4 feet, goes out and upwards another 4 feet. So,
down.
Depending on where you are.
Down.
Stood. Well, if you stood at the apex, one arm goes up 4 feet and the other arm goes down 4 feet.
Yeah.
Elevation change. A rise and a fall. You know, originally, I see, we did the rolling balls. Where do you think you would put a ball, right, for maximum travel? Have we got that picture on as well?
On LIGO? They told us. We don't have to wonder. They actually told us, bro. You put a ball bearing on either end of the arms, which are 2.5 miles long, and the ball bearings will roll to the center.
No, with this one, do you reckon?
But this is different. No. We're talking about the previous.
God.
Yeah. You're talking about a different LIGO there.
Yeah. Well, let's just say math isn't their best bit.
We're talking about this one of Blues that we're dealing with. The one that Blue's talking about.
Just look at the frigging elevation, Sissy. Duh.
Gonna give it away.
Holy shit.
Oh, well, I think we get that. So, how long was your video again, Blue? 10 minutes or so? 12 minutes?
12 minutes. Yeah. And they spend 4 hours going over a 12-minute video.
Well, about 3 hours of it was Bev repeating everything that you said about 4 times.
Pity you can't get a view for every time he said something. It's repeated your video. What he said in your video. You get a few. Look, that's enough of that.
Yeah. Toward the end of it, I was over in the chat busting his chops. So.
Oh, were you? Hang on. Let's nick to the end. We'll see. Oops, sorry. Let's go back to there. Yeah. Okay.
Elevation profiles.
Yeah, there you go.
I'm not too sure it works like Blue. Elevation profiles are from circles.
Yes, they can be.
Is that why horizontals curve upwards?
Yeah,
circles
they are. There's sections of circles, but
or is horizontal curving upwards a consequence of circles being straight, elevation profile wise?
Yes, actually, technically,
Blue
yes,
Marble
that is
says
correct.
elevation profiles are heights above a datum.
Yep.
Yeah, normally mean sea level. Wait. In the case of the circle drawing, the datum is the center of the circle.
No.
Doesn't have to be, but
no, doesn't have
can
to
be.
If it's a curve, it's the
when
datum
you
can be the curve.
Have
curve obviously has a center.
the
so
datum
arguably.
as the center of the circle. Then the circumference is your elevation profile. As it is,
No.
the circle is the circle.
No, your
Already
datum is
with the
datum.
datum at the center.
The elevation profile is the difference between
Blue. Don't think there's
that
any
and
need for you to straighten the circle.
well, it is if the
Blue.
circle is difficult enough.
Is that an upwards curve, or is that a downwards curve? Because you said, I'm pretty sure you said the tangent point was at the bottom, and both of the arms for the LIGO Hanford go upwards. Both of the arms for
That's
LIGO
Hanford.
at Hanford are meant to be on a horizontal. They go upwards.
I don't know, Hanford.
That's
Is that
what you said. You
happens?
said Blue. I mean, if you
Well-
want to contradict yourself,
Well, Bev, oop is relative to how far down you got to go to get to back to the surface of the sphere that plane is tangent to. You got oop and down confused there, buddy.
Not a surprise.
and now say that they go downwards, well, then that would be a further proof of the globe. A contradictory proof. And then Blue Marble Science contradicting himself. That's Tis Globe. That's how you double down on your globe proofs.
Nutty.
You make a proof with the contradiction or the globe. And then as you deliver your contradictory proof, you contradict yourself. Good day, skeptic.
Get forward.
The tangent point is at the lowest elevation. The curve shows how much drop has to be accounted for.
Yes.
4 foot.
Yes.
Rise. It's not a drop.
It's exactly what that
No.
curve shows.
And then once you've got to the apex, there's another 4 foot rise. Again, no drop.
You can't picture that, can you, Biff?
Or do you mean like once you start off at the tangent point and you measure a 4 foot rise and then another 4 foot rise, then you can say, oh, the curve downwards from here will be, well, it's a straight line slope, 8 foot.
No, nothing.
No.
So I don't know how much drop has to be accounted for. Because once you've gone up 4 foot and up 4 foot, you don't really have to account for anything. You just match them 2 points back up again.
No.
No. No, sorry, numpty.
You didn't up at the hump. You didn't up at the hump if you did it.
Between you, Mike, and Eddie. The tangent elevation is dropping away from horizontal. Are you sure, Blue? Thought the tangent.
Yes.
Thought the tangent was
I'm very
horizontal.
sure about.
Until it started curving. I may act like I'm confused, Blue, but I'm really marking you on all of this.
You are really
These
confused.
These are globe proofs.
You're either confused or just completely full of shit. One of the two, or both, maybe.
Or both, maybe. Yeah.
Oh, this one. This is good. Child, like again, elementary, Blue. Okay, now imagine you're a child, and Blue Marble Science is talking to you. So he's going to say this, Dan Bev. The tangent elevation is dropping away from horizontal, even though the tangent was horizontal earlier. It's not. It's dropping away from horizontal. If you want the elevations, that will straighten out the drop. The drop's vertical. You will straighten out the drop. You have to increase the elevation. Just go higher. That's obvious to a child. I'll read it again in case.
Yeah, of course you would. It's because you didn't work it out the first time. That looks like about it. Well, enough of that.
Mm-hmm.
Enough of that.
Yeah, find something interesting.
Oh, that's painful.
That was painful. Enough of that. Okay, guys. Ooh, sorry, I haven't been watching the chat. Have we still got people out there? I hope so. Oh, who's?
Yeah.
I don't know. Welcome to the channel. Let me just in case someone comes on and tries to. You never know who gets on, what they might try and do. We'll give you a spanner. Okay, I think time for a quiz. So, give me a sec. I've got to cue this up now. Ooh. Oh, I had this. This was something I was going to show, but I didn't get around to it. So, where are you? It's in PowerPoint anyway. PowerPoint. Where's my PowerPoint button? There it is. There we go. I had this. I plotted that up in 12D, which is my road program I do for all my modelling and road programming. Blue. I was able to check what the radii of those two curves were. And that's in feet, obviously. So they're only estimates, of course, because it is works execute data, so it's a little bit off and depends where you pick, etc. But they come out pretty close to Earth radii. Well, I thought it was reasonably close, given that, as you'd expect.
Well, given that you're only going over a 2.5 mile arc segment, yeah, that's very close.
And if I'd spent a bit more time, I could have worked out the better approximation for where the radius were, but I just did it on the fly very quick. And as you see, it's not surprising that the start and the bottom is 0%, and then this one's 0%, and then it curves up from that, as you'd expect. Okay, let me, whoops, switch back to here for a sec so you can't see the quiz. There's no point giving you a quiz if you see it. Oh dear, that's not the right one. Find the right one. Did I save it? I hope I saved it. Yeah, there it is. There we go. Okay, start. No, not start there. Start there. Okay, there we go. There we go. So you guys can see it. You can see it out there, Blue. Should be able to see the. It's all gone quiet. Maybe I've scared everyone off. Okay, we're ready up there in Peanuts. Let's see, here we go. Make sure you speed it up a little bit so you're picking it up. So, trivia question number 1. How many layers of skin does a chameleon have?
Ooh.
I'll give you a clue. It's not 1. And it's not less than 1.
I don't know. 5.
5. We've got a 5. What do you answer that in the Peanuts?
Total guess. I haven't a clue.
5. Yeah, Peanuts.
It changes its skin like the chameleon.
It does. Oh, no. We got the answers. No, give them 10 seconds. 9, 8, 7, 6, 5, 4. You were very close, actually. It's not 5, but it's 4. So, yes.
1 out, that'll do. I don't worry about that. Yeah.
Yeah. That was not too bad.
Mm.
You're pretty close. Next one. What do snakes use to smell? That's a pretty easy one. Wild guess 7.
Yes, that is a bit.
It's a bit easy.
Their tongue.
Their tongue, yes.
Their NASA symbol.
Yeah.
Yeah, that's a symbol. Oh dear, skip one. I think you would have got it anyway. What was the largest lizard in the world? Komodo dragon. You would have got that one.
Yeah.
Who was Saturday Night Live's first celebrity host?
A clue.
No clue.
Yeah, we never got that over here.
I think you're behind a bit, Nerd Alert. Push the speed up button. We're up to who's Saturday Night Live? We didn't. Yeah, no, we didn't get that much here. Not to that extent. So, George Carlin. Now, can anyone tell me who George Carlin?
Oh, yeah, I liked him. He was funny.
Oh, there you go. I didn't even know who he was.
He made me laugh.
Oh, that's a good person to have on the show. Okay. What year saw the launch of the Academy Awards? So you can get closest to the pin.
How long have they been doing that old tripe? 48.
48. 1948 or 48 years?
I reckon it would be earlier than that.
Well, not 1848, is it? Blimey.
I reckon it would have been almost at the start of cinema back in the 20s.
So in the 1920s?
Yeah, I wouldn't say what year, but
I
reckon it'd have to be back then.
There you go. Oh, so no Peanuts are talking to me. Okay. It is very close, actually. 1929.
Wow.
There you go. So it's been a while. I remember someone describing what it was the group of the Hollywood guys thought they'd create these awards so that they can sort of boost their movie thing up and interest, etc. So that's how the Academy basically got started. Which is why it's pretty much Hollywood. Okay, let's do some Rebus puzzles. What's that one? Shame Matt's not here. Matt doesn't seem to get the idea of Rebus puzzles very much, so he's very funny when he tries to work it out.
Oh, those again.
I like Rebus puzzles. They're fun.
Oh, yes. What goes up must come down.
That's it. What goes up must come down. Okay, what's this one? Come on, Peanuts. Give me a guess. I think I've sent him to sleep.
That one's not leaping out at me, I have to say.
No, it's definitely not leaping out at you. Let's do it in the reverse. Yep. Carl, now on to the next one. I'm waiting for your catch. Maybe there's a bit of a lag. Hello all, Carl. G'day, Carl.
That much of a lag.
Okay. Any ideas?
No, that's I say that one's just not coming to me at all.
It's N, and what's happening to the N in terms of colour?
Well, it's fading out, but I'm just like I say, I'm just not seeing it.
Getting lighter. Enlightening.
Really?
Okay, here's a bit more direct one. Here you go. What's that one? You are lagging, Carl.
No, it's about a, I don't know, 10 or 15 second lag.
Yep. We'll give him 10 seconds. G'day, Stefan Rudd.
Don't know.
Okay. Obviously, it's to do with evil. What's the relationship between the bottom one and the top one?
Oh, Carl's had a stab.
Yeah, downright evil. No. It's the lesser of the two evils.
Right, yeah.
There you go. Okay, it's going to be a trivia question. How many seasons did the Oprah Winfrey Show run for?
No idea. Never watched it.
Yeah, we would have heard of it. Grown, says Carl.
Obviously, I've heard of it, but I haven't the faintest idea how long it ran for because I never watched it.
Too many, says Nerd Alert.
Yeah. 450,932. Seems that way.
No, not that many seasons. It went for 25 seasons.
Oh.
That many. Okay. What street goes from State Street at Bowling Green for 13 miles or 21 kilometres through the borough of Manhattan and then 2 miles, 3.2 through the Bronx? Any idea?
Nothing leaps out at me, I have to admit. Not being overly familiar with Manhattan.
Yeah. Not knowing any famous streets in Manhattan?
Oh, none spring to mind at the moment. It's not top of my list, I have to admit.
That might have lots of theatres on it?
Oh, Broadway.
Yeah. Yes, Broadway. Broadway. Okay.
Yeah, over here we just call it the High Street and be done with it.
It's High Street. Makes it easy. Go to each town. Which street's the middle of the town? High Street. Okay, go next town. What's the main street? High Street. Which broadcasting network in the United States is solely dedicated to entertainment, news, and updates? It's a fairly easy one. Any idea? No? Yes? No?
Is it?
BBS. No. Good try, though. Yes. That's the one, Carl. Carl's got it there. It is E. I give you had E News, but yes, it's all the same. E Entertainment.
Oh, never heard of it.
Okay. You might have heard of this one then. What came before the BBC?
BBB?
No.
BBC.
Yeah.
Oh.
UKS.
No.
No, it wasn't UKS.
Yes, it does depend on what you're.
Yeah, Nerd Alert's hit the clue.
Somehow I suspect we're talking about TV and not. Yeah.
Yeah, Nerd Alert's hit the clue there. What came before the BBC? The BBC came before the BBC. So, the British Broadcasting Company came before the currently British Broadcasting Corporation.
BBC is.
Yeah. Now, what was it now? BBC Company or Corporation? One or the other?
It's just the BBC.
No, it changed name from company to corporation. Anyway.
Did they?
Yeah.
Oh, I don't know.
There you go. Who was the host of the Tonight Show?
Yes, but it's just not. Is these all bloody American questions?
Yeah. No, they're not all though. Just had a BBC question.
Haven't the faintest idea who hosted some show. I don't think we ever got over here either.
The only host I can think of is Johnny Carson.
Yeah, it was Johnny Carson. Yes, he went.
Oh, well, there you go.
You didn't know. No idea.
I didn't know, but that's the only one I can think of.
Okay, here you go. What's this one? I won't draw it out, but I'll give him a bit of a chance out in the
pass.
Pass. Can you see any words in there?
Clue.
Can you see any words in there?
I think lots of words in there, but they don't make any sense.
They're not scrambled. There's a word in there. Might be back to front though.
Right.
Okay. If this is basics, BA.
Back to basics.
Yep. Back to basics. Yeah, you got to think of it. Okay, there you go. A little bit easier one. Well, I thought it was easier. Oh dear. Oh dear. Come and note it. I think you can get this one. Yay, Carl got it. There you go. Unbalanced. And there you go. I won't draw this one out. Well done, Carl. See if you can get that one, Carl. Lucky guess. Well, that's pretty
square head.
It's close. What's another type of head that might fit that shape?
Box head.
Yeah. Close. Blockhead. That's blockhead. Good enough. I think you're close enough.
Really?
Yeah.
Sure about that.
Okay. Whoa. Whoa. Just see the answers there. Oh, there.
All right, I didn't see.
What happened there? Gross. I'll go through and check to make sure all these things don't happen. I don't know. Let's have a quick look. Oh dear. I see. Sorry. 2 seconds to fix. What are you doing?
Yeah, mate.
Why did you do that? Stupid PowerPoint. Okay. Yeah, the next one's okay. Good. Okay, where are we up to? Play. Transfer. Try again. Okay. What's the only film to win, that is, or should have been, a Razzie and an Oscar?
Razzie and an Oscar. Oh, Christ. No, nothing.
1984, I think, is your
up.
clue. Twins, no. It's got to be a film that was considered good.
No way that ever won an Oscar.
No, Twins didn't win an Oscar. No, not that I can think of. Ah, okay. It was Wall Street. 1987. Oh, 1987, sorry, not 84.
That won an Oscar?
Yeah, it won an Oscar for Best Actor.
Just shows how ludicrous the Oscars are.
And won a Razzie for Worst Supporting Actress. There you go. Ah, no, none of you will get this. Because I didn't know either. There you go. How many people even know what a Vocaloid is?
What?
I knew what a Vocaloid was, but I didn't know the characters. So, anyway. Move on. Which YouTube
You're talking gibberish now.
Yes. Vocaloid is a anime series, for want of a better description. Which YouTube, that's one word, not two, video has over 12 billion views?
Oh god, there's got to be some shit in it.
No, it's not Gangnam Style. Tongue. What's tongue? Judy, I hope you're not right back at Snake. Otherwise, if you are, you've got a very big leg.
You might want to catch up a bit. Tongue.
There's a little bit further ahead than that.
Oh.
Not that Baby Shark crap, is it?
It is. Baby Shark.
Oh, God.
Told you for shit.
It's by far the most watched.
Oh.
Yeah. David at the dentist.
Fleetwood
Mac.
Isn't it?
Fleetwood Mac, no. Why? Baby Shark, do 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 do. Baby Shark, do do. Because it's so catchy. Okay. Whose last words were Kabatsus?
Oh, that's an easy one. I'm not even going to bother answering it. I mean, that's just insulting if you don't know that one.
We'll see if anyone else gets it out.
Speg.
Come on, 700 Peanuts has got to get that one.
Give his full name if you want.
Groucho Marx. No, it wasn't Groucho Marx.
No. It was Arnold Judas Rimmer III.
Yeah.
Yeah. Arnold Rimmer.
BSc SSC. Bronze swimming certificate. Silver swimming certificate.
Yes. Okay.
Because he sent it back and said, "This is cold. Could you warm it up, please?"
Yeah.
Yes, that's right.
Dear.
Okay. Anyone know? Anyone know any hotels in?
No.
See if you give it a few seconds. Anyone out there know?
And yes, Carl, it was series 4 through to about 7.
Yeah, the earlier ones were much better than they did get a bit weird at the end, particularly when they did the sort of remake.
The very first ones weren't as good as the late ones. Once they got Crichton sorted out, and once they because the original Crichton couldn't relocate, so they got Robert Llewellyn in instead, and then it all just clicked. Everything just worked seamlessly.
Yes, got to admit the first one was a bit flat, but yes, it did start to make sense. Well, as much sense as it does. Raffles Hotel, by the way, if anyone wants to know. Okay, let's start with Raffles. Yeah. Okay, let's torture you with some more Rebus puzzles. Okay, there you go. Anyone? Raffles. It was Raffles Story. Nope, still no idea. Okay, that's not still no idea. Oh, I get it. No, now that we've told you the answer, still no idea what Raffles is. Okay. Any idea here? Can't you see any pattern? The trick with these things is to try and work out the words and then, or whatever, and then, okay, so what's the first word? What's W-H-E-Y spell?
Wade.
And what's the second word spell?
Way.
And what's happened to them?
Somebody's fucked about with them. I'm just not seeing it.
That's right. Parting of the ways.
It's a bit shit.
Okay, what's that one?
Midnight.
Split way. Yeah, that's right. It is midnight. Very good. I was going to say actually,
Yeah,
I'd give you that. Split ways, I think, is just as good as parting of the ways, but parting of the ways is a little bit more accurate. Middle of the night. I'd give middle of the night as well, but midnight is better. Okay. What's that one?
Six of one, half a dozen of the other.
That's it. 6 of one, half a dozen of the other. Yes.
Fair enough.
Yeah. Yep. That's the way. One next to the other. No. It's false closer. Which country? Here's an easy one. Well, maybe it's easy for here. Does nasi goreng come from? I'm guessing Paul knows this. I know Paul knows this. Yes, nerd alert. That is correct. Indonesia. It's basically fried rice, farmers. It's a type of fried rice. Yeah. We would know because we're so close to Indonesia. But
yeah, we're not.
No. Okay. Which city was... What? I had no idea what currywurst was, but which city was currywurst invented?
Pass.
Pass.
It's tempted to say India, isn't it?
Yes. Berlin / yes, that's a bit better answer. Berlin. Because, yes, Carl, Germany is not a city. Which country is famous for fast food chain Jollibee? I had to look this up.
Never heard of them.
No,
Can't say I've heard of them.
I hadn't heard of them either. So there we go. Philippines, apparently. No one got it out there either.
Right, okay.
It's all right. Apparently they're famous. Never heard of them. What chain of Canadian coffee cup do you find? Timbits. You would have heard of these, though.
I don't do coffee shops.
No.
I don't do Canadian coffee shops.
Obviously. If you don't do coffee shops, then you don't do
I've
Canadian.
got a perfectly good kettle in the kitchen, thank you.
Do you have international roast for coffee? Maybe you have something worse over there. International roast is what, like one of the cheapest of the cheapest instant coffees.
Like I say, I don't do coffee shops. Full stop. I don't go in them.
It is Tim Hortons. I didn't get any answer. Carl's tried.
Oh.
Tim Hortons. Okay. Do you know this one? Kimchi is a popular side dish from where?
Oh, I've heard of kimchi. Where the fuck's that from?
Korea.
Korea is correct.
Sounds a bit that way, doesn't it? Oh, yeah, yeah.
I can't say it looks overly appetizing, but yes, Korea, Judy, that is correct. Okay.
Let's see what it looks like. Oh.
It sort of looks like it's got capsicum and other things mixed up in.
It's all right.
Traditional Korean banchan consisting of salted and fermented vegetables.
Yeah.
Most commonly using napa cabbage or Korean radish. I'll give that one a miss, thank you.
Nick down. Okay. What's that one? Easy. Actually, that one's
Doesn't give us a lot to work with. What does it? Just says please.
It's relatively easy, that one. It says, please, think of something a word, phrase, anything that might have please in it. Yay, Judy got it. Pretty please. It's pretty.
Really?
Please. Well, the please is pretty.
You think that font is pretty?
Well, it's not ugly. Anyway.
Oh,
I did this one already.
Midnight.
Oh,
I did that one.
again.
6 of one, half of the other.
That's the other. I know that one.
I must have. I thought I'd changed them. I thought I'd changed them.
That's Timbo's memory again.
I went back and didn't change them. Doesn't matter. Okay.
Copied one slide to the next slide and then forgot to change the contents of the slide.
Well, I changed the first one.
Yeah.
And I remember I did this, I don't know, maybe some ridiculous hour in the night. And I looked at it and thought, I thought I had to go back and do one. And then I looked just, you know how on PowerPoint you get the thumbnails down the side? And I thought, I've got enough thumbnails. Yeah, that's right. That must be right. Okay.
When was Guinness the beer invented? When the Irish couldn't find anything decent to drink?
Give me.
Oh, that's been around for a while, hasn't it?
Earlier than that, Carl. Earlier than that. Much earlier.
I'd guess somewhere in maybe the 1700s, but I don't know. I don't drink Guinness either. Bloody awful stuff.
Yeah.
1759.
It looks like it's going to be a hell of a pint, and then drink it, you go, well, it's just thin water. It's just a load of rubbish.
There you go. 1759. And it's not.
Yeah.
So it holds the Guinness Book of Records for being the first oldest Guinness. Guinness Book of Records supposedly invented to stop bar fights. What is the popular dessert served in Japan during the summer months? See if anyone's got any idea. Asian culture. I'll give anyone an inside. Anyone from the outside?
I have no idea.
Yeah. Kakagori is what it's correctly called. What is the difference between jelly and jam? Any idea? Is there a difference? Viscosity, says Judy.
I suspect it's to do with how they're made, but I don't quite know how you describe it.
It is. Jam has seeds.
Not necessarily.
Not seeds. I wouldn't want seeds in my jam, I've got to admit.
Oh, no, you've got to leave the bits in.
You leave the bits, but not seeds. You don't have to pick your seeds out of your jam. You get rid of the seeds.
I agree with that.
Well, you leave the seeds in.
You can buy both sorts. You can buy jam as it is and then jam that's had all the seeds and bits took out.
Well, I know jam sets with pectin and jelly set with gelatin.
Yeah, it's not the answer though. Okay. According to the internet. Yes, that's close enough, John, I think. Jelly is made by straining the fruit juice and jam is made by mashing the fruit. So there you go. So you get a much finer jelly texture for jelly. So anyway, there you go. I didn't know you had fruit seeds in your jam. Who buys that? Pain in the neck. It's like having fish bones in your fish.
I do for a start. You want the interesting bits left in.
Anyway, I'm sure you know this one. Kebab. No, not a kebab. Different country.
It's fine.
Kebabs are more Middle Eastern.
Yeah.
No? Paul, you got any idea? What would we call it? Any idea? No one. I'm quite surprised that people would get that one. It's satay. Satay.
Oh, right. Yeah.
On a stick.
Eat that sort of thing.
That's called satay. Has peanuts a lot in the sauce.
Rattle stick.
Yeah. Which province of China is known for its spicy chili peppers? No? No one? Yeah, there it is. Netherlands has it. Sichuan.
Oh, is it?
Yeah,
Wasn't aware of that.
Yes. Very well known for its it's the most spicy of the Chinese foods. Yes, John, that's right. Okay, last of the puzzles. What's that one? And it's not Darth Vader.
Space Invaders.
Yay, there you go. That's great. Space Invaders. What's that one?
Lead Horizontal.
Close. Invaders. Space. Yay, Carl got it. Split level.
Split level, yes.
Okay.
Sorry, what was that, Blue? I missed that.
I said split level.
Yep, that's right. And what's that one? This is what happens when you watch too many Flat Earth videos. During the
behind
day.
with my work.
Behind in my work.
Oh, right.
Yes. Behind in my work. Yes. No, I got that. So there we go. That's the quiz for the day.
Oh, thank you very much.
There you go. Thank you.
Sorry about that, but yes. Oh, you don't want to see that. What else? I'll put up some more LIGO because I just happen to have that button ready.
What?
Sorry?
LIGO missed out the W.
What? Wait, who? What? Oh, sorry, yes. LIGO. Yes. Why didn't I get that one? Yes. No clue at all. How about you want some Everett? Something a little bit more jolly. Let's put in some Everett. 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 There we go.
Oh, idiot.
All right, let's talk flat Earth.
Yep.
The Earth spins at 1,000 miles an hour around the equator. Come on, 1,000 miles an hour.
I just can't believe it. I'm appalled. What do you make of it, Bernard?
I'm appalled. So down here at the bottom, this is just a commercial jetliner. 500 miles an hour. How long will it take that plane to get to where it needs to go? When the spin is twice as fast in the opposite rotation.
What was that?
What? There's nothing there.
I know that, but when I turned my neck, I heard something pop.
Well, there goes that last brain cell. It's not spinning, it's stationary. 1,000 miles an hour. What is holding it down? All the water would be flinging. What holds it on this ball?
Gravity.
Gravity. Well, that ball is 70% water.
It's not.
It is
No.
not. Yes, it is.
Surface
No,
might
it's not.
be.
Yes, it is.
So the 70% of this ball, this water's
Oh,
stuck
Ed was just
because of
playing
all this
guess the clip.
gravitational force that you're talking about.
Damn, stop, please.
That's correct.
But yet,
not sure
this
about that
little
one.
butterfly
This is
and that little dove is just floating through
Keep
the
going.
air.
Oh, God.
No, that one. No, the clip.
Not again. Sorry.
It doesn't make any sense. Why does it make any sense? Because that gravity that's holding down all that
'Cause you're
water
senseless.
that weighs 8.34 pounds a gallon is not holding down that butterfly or that bird.
Social credit deducted.
It is not holding down little Johnny Two Goods in his air balloon that wants to draw a picture of the countryside.
This is a national simpleton emergency. Important instructions will follow. The Department of Homeland Security has issued a simpleton warning. If seen, do not look at or engage in conversations with the simpleton.
What is it? He's changing the molecular structure around him.
Oh no.
You got air, you have nitrogen. You're changing this output of these chemicals, these gases. It's called density and buoyancy.
What's density and buoyancy got to do with changing gases?
No. It's not gravity. There's no force holding him down.
This needs to stop now.
There are magnetic poles, but there's not a gravitational force in the fact that it can pick and choose what it reacts against.
This needs to stop now. This is cancer.
It will hold down water, won't touch a butterfly.
That's from Black Books.
It'll drag your ass fucking right back down to earth when you jump off the top of a building. But yet that little bird with hollow bones is just going to fly right through.
Not if it doesn't
God,
flap
it's
its
just
wings,
so
it's
sad
not.
that your time came and went. Hundreds of years ago. It was hundreds of years ago, fucknut. Okay? You want to believe in a flat earth, go create a 14th century village somewhere and give yourself the plague. Have rats running around.
Yeah. Why not?
Yes. Well, I think we're coming to a close. Blue, if you're still there. Who's still there? Can't tell. Look. Thanks for your video. That was good. Enjoyed it. I think I might, just for the fun of it, draw a elevation profile with a curved datum, just to sort of hammer home the point. But you guys, I have to say goodnight there. So let me just finish off. I'll say goodnight to the Peanuts. Thanks for coming, Peanuts. It's good to see you here. And again, we will be here. Sorry, they can't see you. Let me make it so they can see you, farmers. Too many.
You don't have to. Don't have to inflict me on them.
Oh yeah, I'm sure they want to see your. Here we go. Now you can wave.
Oh, this is the joy of buying second-hand books from Oxfam.
Yeah.
Turned up the other day. It's as old as I am.
What? 17.
1970. This book was printed. It cost 105 shillings, apparently.
Right. What's your name in that one?
Oh, yeah, 1970. That's 53 years old.
I think one of my favourite books is this fishing book that was my dad's, and it's about put it in your terms, what, about 3-4 inches thick. It's fascinated me, and it covered every possible fish and every possible location around Australia you could go, so you could look up, what to do, how do you catch the fish, what line to put out. Yes, hard to get now, but it's a very good book.
I only got this because I've been reading some books about the Pacific campaign, and they keep going on about various Japanese aircraft. Not much of that. So this, although it's 53 years old, is still perfect good, because they refer to a plane. You think, what does that look like? What was that capable of? And you just go in there and have a look. You know, it's only, I don't know, 10, 12 pounds something, but. But yeah, when I looked inside the cover, I thought, Christ, it's the same age I am. Bloody hell.
Hey, I'm about to push the button. You want to say goodbye to the peanuts?
Push the button. Thank you, Peanuts. Thank you for your attendance.
Thanks, guys. See you next time.
Bye, peanuts.
Good night.
Good night.